make sure your ringers are off.
Yeah, but
My
turn
phone's
mine
off.
off.
All right, yeah, make sure all the ringers are off. Okay, this doesn't look too bad. This looks, I don't mind doing this.
It looks pretty good.
All right, for everyone who's streamed, can they hear us right now? Can you hear us, everyone?
Can we get any affirmatives?
Actually, I can just put this stream. Yep, we're good.
Would you like a breath mint?
Are you implying something? No.
No.
I'm fine, thanks.
Okay. All right,
I just ate some tandoori chicken.
we will now start in 5, 4, 3, 2, 1. Give it up for Elan Barenholtz and Daniel Vanzandt. So we're here to welcome you to the University of Waterloo. This is an extremely fun time for us for you to be an international speaker already this quickly. And I think everyone here is going to be very curious about what you have to say about, is memory real? What is language? And for those of you who don't know, Elan and Dan have been working on some incredibly important ideas as to the nature of language, perception, memory, the things that we hold very dear to our way of interacting with ourselves and other people. And so I think maybe you'd say it better than me. Why don't you take it away?
All right, thanks everybody.
Speak louder.
Okay,
Yes.
hope you can hear me. So so I've been working for, let me say, about a year now on the big epiphany, and it's not my epiphany. It's my epiphany in relation to what's going on in artificial intelligence. Everybody knows that these language models are rocking the world, and it's an incredible engineering feat, and it's obviously has massive impacts. It's going to have massive impacts on just about everything. And what I've been thinking about is not so much the practical implications, but what this tells us about the nature of language, the nature of mind. I've come to believe that maybe we've discovered a computational framework that has very broad applications, like maybe even foundations of physics. And it all starts with this simple observation, which is that language models are able to achieve full competency in natural language. If you agree with that, and not everybody does, but the benchmarks are falling quickly. They have to come up with new benchmarks all the time. Some of them non-linguistic, like spatial benchmarks. If you spend some time with ChatGPT or Gemini or Claude, I think it's hard to not come away with the impression that they have mastered the art of talking, that they have essentially been able to crack this thing we call language. And the big realization here is that the sort of inescapable conclusion as far as this technology goes is that the ability to have linguistic competence, the ability to talk, doesn't depend on anything but learning the statistical relations between words themselves. All of the models ever have access to, we can get into multimodal, but let's leave that aside. Models that just are exposed to digitized text, which is, if you think about GPT, all that it has ever encountered is the corpus of digitized text from the internet. And what it's learned is just the relationship between words. And it hasn't learned what those words refer to in the colloquial sense. It doesn't have a concept of an external world that the words point to, and yet it's able to achieve this incredible linguistic competency across lots of different, very diverse capabilities. It can talk about whatever you want to talk about. It can freestyle rap if you want. It can write poetry. It can talk about deep philosophical concepts. It can talk about very highly technical concepts. It can read papers, summarize them for you. I think most people watching and most people here know what these competencies are. All of that without any actual notion of what those words refer to outside of the words, the corpus itself. And so the insight here is not actually really about the models, because the models are generic learners. The models are just learning any sort of structure, the geometric structure that allows for them to be able to do this thing, this next token prediction, which is basically given a sequence, what's the next likely word? Really, it's a token, but don't need to get into that. You can think about it really, for all intents and purposes, think about it as the next word. All they're doing is saying, given this particular sequence, what's the next token? And then they take that token, tack it onto the sequence, and then run it again. This is the autoregression. It's autoregressive because it's doing regression on the sequence, using that as its prediction, and then taking its own prediction, recursively feeding them back into itself. And that's sufficient. By learning to do that task from the entire corpus, it's able to do language. And so the sort of core epiphany here is that language it's not about the models, that these models are so smart. It's that language itself, the corpus of language, contains within it its own autogenerative capacity. That language is inherently predictive. That all these models are doing is learning the structure. They're just modeling the structure, and based on that structure, they're able to do this prediction. And so the key insight here is that language has this fundamental property, that it's self-predictive, and that is how language runs. Now, the thesis, if we can call it that, sort of my thesis, is that that's true of language generally. It's true not only of large language models, but it's true of language in human brains. That what our brains are doing computationally, without getting into the physiology, although it's something I'm thinking about quite a bit, is this next token generation. It's this predictive process. And we'll probably get into a little bit about why I think that's true. But on this sort of the core fundamental argument is, if language already contains this structure, it would be very odd if human language was doing something completely indifferent, completely orthogonal to that. That what human language is doing, for example, is using some sort of world model that is necessary in order to ground language. Instead, it seems like language, it runs itself. Language is its own, in some ways, own autonomous informational system. And it can run in silicon. It could also run in wetware. And so this then takes us to human language as being this kind of autogenerative process. And that means that language isn't what we thought it was, that language is ungrounded. Despite the fact that I can talk to you and say, hey, there's a blue chair over there, can you grab it? This is my friend Daniel over here, my student, and my friend Daniel. And that does things in your brain. For example, if you didn't know there was a blue chair, now you walked into the room, you wouldn't be surprised to find that there's a blue chair there. However, that happens in this very indirect fashion. And that's sort of the weird conclusion you have to draw here, is that if language contains all of the structure it needs in order to generate itself, there's no room for other kinds of computational work to be done. The predictive system doesn't actually have the capacity for other kinds of computational structure to make it run. And so this leads to this very odd kind of conclusion, which is that language is just kind of running in us, kind of as an almost semi-autonomous system, and it's interacting with the other systems. It's interacting with perception, like it's message passing with perception. But in a very real way, when I say there's a blue chair over there, those words don't mean what I think they mean. And then you start to get into these very difficult kind of situations linguistically, because I'm speaking, but when I say I don't mean the perceptual I, because it's the linguistic I. And it leads you to some very strange paradoxes. But the core claim that I'm making is that ultimately what we've done, and I don't mean me, I mean as a species, by building these language models, is we've come to some a radical new perspective in the nature of thought, the nature of cognition, and the nature of knowledge itself, which is that linguistic knowledge is not what we thought it is. And now the hard work is figuring out what it actually is. Now, the topic of today's discussion is memory real? And that's based on a little bit of an extension of this model. The idea is that not only is language generally autogenerative and autoregressive, but that's probably broadly true of cognition. So the extended version of this model is that language is built on this autoregressive machinery, this predictive machinery. What you do is at any given moment, your brain is in a certain state, and then it, based on that state and based on the inputs, it produces its next state. I think of it as it's a cognitive token. It says, okay, given this state, what should my next state be? This is what's get optimized in the course of development. And that state could be linguistic. It could also be an action. It could be an image. And then you take that state, and then that state serves as the autoregressive context, the context for generating the next state. And that what we're doing is we're just in the they call it the pregnant present. We're in this continuous single flop.
The pregnant present?
The pregnant present.
I love the comments on that one.
So the pregnant present is the idea that this present, that this single token, next token generation, contains within it the past, namely the previous generated sequence, that somehow there's this residual activation that's stored in some capacity in the brain. And then based on that, we actually can produce not just we produce just a single token. And I need to point this out, that these, the large language models, Anthropic just recently published a paper on this idea. Even though the models are doing next token generation, so like if you say to ChatGPT, tell me a story, and maybe it'll start with the word once, and then upon a time or something like that. When it produces that word once, there's a certain sense in which you're like, wait, you know what's coming after that. Clearly, it sort of has that. It seems to have that idea in mind. Why would that word by itself isn't the answer to the question of tell me a story? And so the pregnant present is based on the fact that the autoregressive process, by virtue of the fact that what the models learn is actually trajectories. What they're learning is an evolving sequence. What they learn is that given this entire sequence, what should I do next such that this sequence will continue along a path that's optimized? And so the pregnant present is pregnant with the past because it's taking the past into consideration in producing the next token such that it's going to lead to a trajectory, a smooth trajectory into the future. And there, as I mentioned, there's an interesting Anthropic paper whose title I can't remember right now. Maybe we can, somebody can put it in the messages. I think it's the biology of large language models or something like that. And you can see the activations actually in the weights. You can actually decode them to some extent as showing some activation that corresponds to or is decodable as corresponding to, say, a future token. Let's say in a rhyme. You can actually see a word that rhymes with a past word showing up, even though it's not actually the next token. But it's very important to note here that it's not thinking about that in the traditional sense. It's not expressing that the way when we think of the future, we're actually doing it autogeneratively. I'm thinking, well, if I do this and I do this, but you're doing it one token at a time. Similarly, these models are doing everything one token at a time. They're not actually thinking about that word. But what's happening is you sort of, I call it the ghost of the future. With that word, the thing that is sort of called for in the future because of the trajectories going there is actually impacting what it's doing right now. Okay, so I've said a lot already, but I want to get to this point about memory and today's conversation. And the idea that is, the reason this is, one of the reasons is a very radical approach is it's not just about language. As I said, it's more broadly about cognition. And the basic formulation is this, that our brain is just a next token generator. And what we call long-term memory is just the weights. It's the state of the brain. The state of the brain doesn't have within it a memory in the traditional sense. If I say to you, what'd you do last summer? If I say to you, what have I talked about today up till now? If I say to you, can you recite an O Canada or something? I usually use the Pledge of Allegiance for some reason, but I guess you're probably not familiar with that one. So you can do that, right? You can recite the words of something you've memorized, or tell me about some event that happened in the past. And the conventional, traditional perspective on this, the sort of idea that almost everybody, there's the folk psychology idea, is that we've got that information stored in our brains. And what we're doing is the storage and retrieval model. And this is dominated all of cognitive science since cognitive science has existed for 60 or 70 years. It's also dominated to a large extent computer architecture, which is based on a storage and retrieval kind of long-term memory, even RAM. This is basically what a lot of computing consists of. But the autoregressive model doesn't do that. The autoregressive model says you don't actually have the particular sequence stored in your mind. If you were to go into your brain and you could decode what the neurons actually contain, if you looked at the weights, you're not actually going to find that sequence there because the sequence isn't there. The sequence happens when you run it. The sequence only occurs when you do it autoaggressively. If I say to you, recite "Oh Canada," I'm sorry if that's an embarrassing example. I don't know if you guys all know that or something. But if I say that to you, well, that's your prompt, right? And then all you do is next token. And then that next token gets fed into your context, and then you do the following token. And so what you've got is what I call potentialities. You've got the state of your brain. The state of your brain is ready to take in a sequence. If it's halfway through, ABCs is probably a better example. If I say, what's the letter after L? Or what's the letter after R? What you might do when you're trying to perform that task is you might sort of think to yourself the sequence up to that, right? You're not necessarily going to start from R, so you say Q, R, S, or something like that. What you're doing is you're feeding yourself the sequence, pulling out the next token. And so the idea is that sequences, events, really even memories of facts aren't actually stored in our brains. Instead, what are stored in our brains is the potential to produce those facts in response to the appropriate input. And so this really accounts for, in some ways, the incredible flexibility, the general the productivity of the brain. The fact is, you have infinite capacity of your brain, even from a basic fact about, we could talk about like the configuration of chairs in this room. We could theoretically talk about that almost forever, because I could ask you stupid questions like, is that chair to the left of that chair? If I move that chair a little bit, how much closer would it be? There's sort of an infinite number of possible facts that could emerge from just thinking about the configuration of this room. Well, the same thing holds for our brains. What we've got is these weights, and the weights have this capacity to produce an infinite number of possible sequences. But the beauty of it, of course, is that these sequences are not arbitrary. If you take an untrained model, it can produce autoregressive junk. It can say, whatever, it can produce nonsense sequences. But by optimizing our brain through the course of development, the course of learning about the actual sequences in the world, experiencing linguistic sequences, experiencing perceptual sequences, what our brain has mastered actually is this autoregressive generation capacity, so that we can think about what would it be like if I would reach for an object and had to reach a certain, how far do I have to reach to do it? And so my brain can map that out because it can run the sequence and then actually generate the motor sequence in order to do it. And similarly for language, similarly for imagery. So we've learned these trajectories through space, but they're extraordinarily flexible, such that you can, the same way in the large language models, you can mess around with temperature. The large language models are trained to optimize the likely outcome of a particular sequence. But what they actually produce is a distribution. What they actually produce is, like, given this sequence, whatever sequence, whenever I have to think of something generic, of course I can't, right? But you know what? It's just a good insight. You know why? You know why you can't think of something generic? Because there's not a good input. Because you need this. It's like a non-prompted generation. So I just came up with a good explanation of why I stumble right now, coming up with like the most obvious thing, like the one that the AI people always use. The cat sat on the mat. Right now, the answer could also be the cat sat on the couch, or the cat sat on my head, or the cat sat yesterday, right? And so you can, what the models will do, by the way, is they'll create a distribution of the possible next token. And then there's this temperature thing where you could say, I'm not going to necessarily pick the most likely, I'm going to pick the second most likely or the third most likely. And so you can go off and meander into different directions, but they will be very coherent and very meaningful. And so that's this incredible flexibility. And in the case of human creativity, the case of human generation, we're not only thinking linguistically when we're thinking linguistically. I'm taking into account my emotional state. I'm taking into account the people sitting in this room. I'm taking into account things that I remember from the past. And all of those things are converging as the prompt. They are all part of the prompt. And those are driving what that generation is. Now, so long-term memory is just this ability to generate the next token is, again, it's the pregnant present, so it has within it this capacity to do this smooth trajectory. It's not just next token, really, it's next token with longer trajectories in mind. And then short-term memory in this system is just a contextual buffer. It's just the residual activation, which is just like it's like when you're talking to GPT, it's got the whole conversation, not only the conversation, what you've asked it, but also how it's responded. We are kind of doing that. We are holding in mind what we've talked about up till now. For example, if you're listening to me now, and if you have any clue, maybe I've lost you, but if I haven't completely lost you, you kind of have an idea of what I've been talking about. Well, you're not just remembering the last couple of words. You're not, as the cognitive scientists say, the short-term memory, you're not really just remembering the last 15 seconds, which is the sort of the orthodoxy of cognitive science, that there's this thing called short-term memory. My conjecture is, no, we have this residual activation that lasts minutes, maybe hours if you're having a long conversation, maybe longer. And it's not the same thing as long-term memory. Long-term memory is the stored weights that gets changed during consolidation, things like that. This is actually the residual activation. It's what happened most recently. You can't remember things verbatim necessarily because it does decay, but it's driving your generation. So long-term memory is just the ability to do next token. Short-term memory is the contextual activation that drives your next token generation based on those weights. So that's the input sequence. And then you just run. And by the way, one last thing, attention. And the thing, maybe even what we call consciousness, is the autogenerative loop. It's the reason why you got to think about stuff and it takes time is because you're running an autoregressive process, and you have to do that sequentially. You can't instantaneously know and respond to certain kinds of questions because you have to think it through. It's kind of like when you watch Chain of Thought in the large language models. What takes them time? It's not a single flop. It's not, here's the model, here's the function, input, output. Like, wouldn't that be nice, right? If the models could run that way, and diffusion models kind of approximately try to do this. If you said, hey, give me a good summary of this paper, and it just went boom, done. But that's not how they work. They can't work that way. They have to do it autoregressively. They just say, oh, what's the next token? What's the next token? And you see it actually spit out on the screen. So that's basically the version of cognition that I think that these models point to. And so attention is this sort of recursive autoregressive loop. Maybe that's even why it has subjectivity, because it's inherently recursive, it's inherently self-referential, but that's a little bit too far. But in this version of things, memory doesn't really exist in the traditional sense that we think. When you say that we have a memory of something, we tend to think that memory is like stored facts, stored maybe even episodes, like you have a memory of your birthday party or your mom or something like that. But in my version of what memory is, it's that if I say to you, what did you do last summer? Or you think to yourself, what was my mom wearing yesterday? You have the capacity to generate in that moment. And given that prompt, you have the capacity to generate that. Given a different prompt, you generate something completely different. So there isn't a stored actual static memory that exists. There's nothing like engrams in this model. You could never read off the memories off of a brain. The only way to read them off is to run it. And so it's an inherently dynamic system. And so the dynamical aspect of this is really, really fundamental. The present, it's again, the pregnant present, is you have to run it in order to even say that it's doing its computation. Now, my student here, Daniel, has a different view of this, which we like to fight about, and has actually built.
Professor and student fighting?
So technically, I'm his advisor, but I would say he spent the past couple of years in some ways, ignoring my advice, and it served him very well because he's actually built out an extremely impressive piece of software that in some ways really it depends on instantiating knowledge as knowledge, and in a more traditional sense. So I'm going to hand over the conversation to you to maybe counterpoint.
Yeah. You gave me a doozy of a block of conversation to counterpoint here.
I hope you have it all in your autoregressive buffer. You better.
All right. Well, I'll introduce myself real quick first. My name's Daniel. I am a PhD candidate at Florida Atlantic University, and I'm also doing startup things. My advisor Elan and I are both obsessed with large language models, and we have been pretty much since. I guess we've been pretty interested in natural language processing since GPT-2 and BERT and all of that. So even before the chat GPT moment, we were interested in all of this. If there was a way to section us off with sort of within that, I would say you're very interested in sort of the theory and what this implies for the brain. I'm interested in saying, oh my gosh, these things are cool. What can we do with them? And so as a little bit of background on me, I have training in neuroscience and machine learning and natural language processing. And sort of the final part of my introduction, what I'm doing right now is I'm working on taking these things and applying them. I'm building a system to help knowledge workers in different ways. And the system very much relies on taking the knowledge out of the large language model and representing it as a separate system that it stores and retrieves from and all of that other stuff. And one application of this system that I'm really excited about, and Elan here is helping me with some, is that there is a huge gap in success rates for treatments for neural diseases or diseases that affect the central nervous system. A lot of people much smarter than me say that this is because we don't have nearly as good of theories or robust theories about the brain as we do about other organs of the body. And so I'm working on a system where a neuroscientist can say, here's my theory about how the brain works, or how this system of the brain works, or how this part of the brain works. And the large language model sort of interface with this knowledge system that they've built from all the papers that exist currently to design experiments and run the experiments and report back to the neuroscientist on whether or not their theory sucks. And ideally, it'll let people iterate on much more robust theories much quicker than is traditionally done in neuroscience. So for your question, and I think the central question of this, is memory real? I want to make this a little bit precise because I think there's sort of two ways you could put this, and one way is one in which I would absolutely agree with you, and it's that memory as it is represented in the brain is not an exact simulation of reality at the moment that the memory happened. Sort of it can't be. And that this is sort of what Michael Levin talks about in the bow tie theory of consciousness, he calls it, where...
Also, isn't Michael Levin speaking tomorrow?
Michael Levin is speaking tomorrow.
Tune in tomorrow?
Yes,
Yep.
Everyone should tune in tomorrow or come tomorrow.
Yes, University of Toronto, not Waterloo.
Yes. Everyone should drive a little bit and come tomorrow.
It's a nice trip. Canada's beautiful.
But yes, Michael Levin is speaking tomorrow. But he has this idea where he says the entire past that's relevant to an organism has to be represented physically in the present. And so Michael Levin, in some sense, believes in the pregnant present. And I think in that sense, I would agree with him that for a physical organism, there really isn't any, the past doesn't really exist. There's just sort of the references to the past that are relevant to what an organism has to do in the future. So all of that to say, that's where I think we absolutely agree, and sort of that abstract sense on what memory is, and maybe memory doesn't match people's intuition. I think where we disagree is you think memory is kind of a one system process. And I think it's funny that you're the advisor and I'm the advisee, because you have the more radical view here and I have the more conservative view here. I think memory is sort of the classical two-system process where you have sort of a system and things are stored there, and then you have a separate system that retrieves things from that system. Or when you have a certain sensory experience, it stores that in the system, or maybe it retrieves something and fiddles with it a little bit and stores a new thing in there that's slightly different when you're updating your understanding of something, things like this. But it's very much a two-process system in biological organisms. And I would say in as much as large language models seem to be able to do this, they're actually secretly a two-process system just being executed in a really weird way. So this is where like computations are arbitrary to the architecture.
Oh, so sorry to interrupt. So you are actually, you're not claiming that the human system is radically different than the large language models. You're reinterpreting the large language models to fit the dual process system.
Yes. And I think, so I think computation is substrate agnostic, and certain processes are substrate agnostic. And large language models are based on this architecture called transformers, transformers are a mathematical computational thing that are referred to as arbitrary function optimizers. And so that means you give them anything and enough data, and they'll optimize a certain function no matter what the actual internals of the function are. So you can use a transformer to do addition with, and the way addition looks in the transformer will look nothing like, all right, I have 2 things and 2 things, and I put them together, and now I have 4 things. But they'll figure out some way to sort of do that in a transformery way. And if you unpack a transformer that does addition, you're going to find that same kind of process in there somewhere. So I'm actually making a very strong claim the other direction, where I think there's some research, actually from Anthropic as well, mostly.
Sure.
Maybe that's just because they're doing most of the interesting language model research right now.
Right now. I got some stuff.
We're working on it.
Stuff cooking.
But I think there's definitely evidence that sort of what they're doing is something like a storage and retrieval system, just sort of approximated with the universal function approximator that is a transformer.
But just to be clear,
yes,
that all these systems do, and what they're optimized to do, is just next token, right? We can't get away from that. And literally what they do is input output, and that output is not a sequence. It's never a sequence. The output is simply the next token of a sequence. And so there's a certain very real sense in which it's almost inescapable to say that they're not truly encoding. What they've encoded is the capacity to do this single pass output. And it's only through the autoregressive process that you get the sequence. Like, it's not, it really isn't in there. It's not in the weights. The capacity, the potential to do it is in the weights, but it only happens through the autoregressive loop. That's sort of where fundamentally I feel that that's not sequence memorization. And it's not pure. It's not a semantic argument. It's that that is really fundamentally what they've learned to do, is to do this kind of autoregressive generation. And then, and if that's the case, then they really haven't encoded. The weights do not contain the memory in the traditional sense. So, if you want to disagree on the large language models, you'll have to convince me how you can still somehow strong arm that into being. But you could also take the position that, well, we're not just doing with the large language models, which I thought was more of your, but it's your theory. You can define it however you want. That in humans, what we do is sort of have a storage database. So people are maybe familiar with retrieval augmented generation, which is one of the things, RAG, which is this guy rags on RAG, rightfully so, because
rags to riches.
Hopefully not rags to riches. Right? That's where you're going. RAGs are notoriously, they're faulty. They make mistakes, as do, of course, large language models hallucinate. Because why do they hallucinate? Because everything's generation. They're always hallucinating. It's just sometimes the hallucination happens to match reality, right? Because they don't actually have stored information. But RAG requires this. You have a corpus. You have not a corpus, but a database. And what you do is you have some sort of way of accessing that database, pulling the information. It's really storage retrieval, and then you pull that in as the input. So that separate process of retrieval is computationally distinct from the core computational loop of a large language model, which is just single flop. Here's a sequence, produce the next token. It's something else. It's go and find the most relevant data from the database, pull it in. My understanding of your position in general was that the brain might have that kind of database, and retrieval process, which I would say that's not just the large language models themselves are not doing that. They're not doing that. They're not doing retrieval in that traditional sense. With RAG, they are. With RAG, that's the two process kind of system, which is. Sorry. No. I think this is a really good way of highlighting where we differ, because am I saying that there are no autoregressive processes in the brain? Absolutely not. What I am saying is that
there's probably an autoregressive process somewhere in the prefrontal cortex, but that isn't everything.
It's everything. Okay.
That's where we disagree, right?
Yeah.
The autoregressive process is hooked up to.
I don't think it's everything. It's just the cortex, the whole cortex.
Yeah.
That's as far as I'm going to go. I don't know if brainstem. I don't know. I think it might be actually in like motor control and like in subcortical systems, but who knows?
And so, and let me explain sort of what my system looks like in LLMs and what it looks like in the brain, and why I sort of think the way I think about these things, and maybe that'll help. So sort of in the brain, the system as I see it now, and again, this is sort of, there's nothing wrong with going against orthodoxy, but you're calling it my theory. This is sort of neuroscience orthodoxy, and that's a good way of putting it.
You're right.
Is that you have sort of
You're the man.
I don't know about that, but that you have memory stored somewhere that's a little bit mysterious where exactly it's stored, and maybe that's evidence to your point. But we do have engrams, so you can sort of, yeah.
We have engrams. Well, that's a matter of interpretation.
We should talk about that too. But memory stored somehow in the brain, and then you have the prefrontal cortex, which is sort of doing a lot of the processing in the brain and a lot of what we think of as cognition. You have the hippocampus, which is grabbing the memory from somewhere in the brain and bringing it into the prefrontal cortex. And then when the prefrontal cortex has generated something interesting, maybe it puts it back somewhere else in the brain. And so you have I would say very physically a two-process system where you have sort of these two core things that are interfacing with each other. And one is mostly retrieval and storage, and the other is mostly
absolutely. That is the conventional perspective.
Yeah. So, and then in large language models, it's a little bit trickier to talk about, because I think in large language models, it's much more obvious to say it's purely autoregressive, and I think I do have to make a stronger statement to say it's not. But if there was a case to make that, though these are sort of approximating something similar, it would be. Have you read any of the monosemanticity papers? Anything? So I'll talk people's ear off about monosemanticity. So there's this cool thing where. It's really hard to understand what neural networks are doing. You guys might have heard that neural networks are like a black box. And the reason for that is because if you look at a particular neuron, what purpose the neuron serves in the computation depends completely on the context. So the same neuron, this same neuron, when you have the sequence, the cat chases A, and then this neuron says, you should do dog, or whatever. Like, that same neuron will be the same neuron that is somewhere in the Pledge of Allegiance generating the next token there, and it'll do something else in this context.
They're Canadian. They don't know about the Pledge of Allegiance. It's a weird American thing we do.
but it's for an individual neuron in a neural network, the purpose it serves computationally is completely subject to context. But something that you can do, and that Anthropic has done. Please hire us, Anthropic, if you're watching this. We'd love to work with you guys. But the thing that Anthropic has done is they've said, well, actually, we can disentangle all of this. It's called polysemanticity. That's what it means when it does a different thing to the computation in different contexts. Is they say, well, actually, we can disentangle this polysemantic network into a monosemantic network, where each neuron only ever means one thing. And it was somewhat surprising to them and somewhat surprising to other people that you could disentangle a polysemantic network into a monosemantic network in this way. And to me, that's sort of a pointer that there might.
So they go back to the grandmother neuron?
Yeah. And the monosemantic network is much larger for obvious reasons, because you're not using your neurons efficiently. You have a separate neuron for each concept. This is the neuron for the Golden Gate Bridge, and this is the neuron for the University of Waterloo, and this is the neuron for that, and this is the neuron for that, and each neuron only means one thing.
I think Anthropic doesn't understand their own interpretation yet. I really believe that. Based on that's the paper I mentioned. I think they're misreading. Because activation and decoding doesn't mean the same thing in an autogenerative framework. And again, I'm not familiar with this particular paper, but I'm suspicious based on what you're describing, because you can get sort of an interpretation whereby you've sort of decoded something as having this sort of representational meaning, but you can do it in a way that it's the cart leading the horse. in some ways. Like if you're asking it to decode it, then that may show up, but that doesn't mean it's what it's doing in the process of autoregression. But I shouldn't speak out of turn because I haven't read the paper.
So you're saying, but what you're saying is sort of the map is not the territory, and in some sense, Anthropic is using a map that's very biased towards sort of the standard model of memory.
Yes.
And because they're using that map or they're using that lens of viewing it, then of course it looks that way.
Right.
Okay. But you're saying that that's not sort of what's naturally there. You're saying that they're...
Yeah, it doesn't play the role that they think it does, because yes, they're using a traditional lens of decoding, which, you know, similar to the activation that looks like the future. It's just that the future has some, so a particular future is sort of embedded somehow within the present, the trajectory, such that it shows up, but it doesn't really mean that that's what that thing means, because it doesn't mean anything outside of whatever it happens to do in the course of the dynamic process. So, but again, I don't think I can critique that particular result that you're referring to, because I don't know enough about it.
Yeah, absolutely. All right. Well, at any rate, I think I can stick to my softer claim, which is that maybe even if LLMs are doing something auto-generative or autoregressive, and I'm not claiming that they're
hard to get out of that one,
secretly a two-system thing in a trench coat, I think I can still make the softer claim, and whatever. Maybe we should both read the paper and talk about that later. But I can still make the softer claim that they figured out a way to do language, and the brain has figured out another way to do language, and the brain's way of doing language is sort of closer to a two-process system. And
language in general, so not just memory retrieval, but for you, it's the language is not happening in this autoregressive way in people.
And so I'm curious if you want to talk a little bit about what n-grams are and sort of what your theory says about n-grams. Because to me, sort of the n-grams are one of the clearest sets of hard evidence that there is some sort of, the memory is in there somewhere and the brain's retrieving it and loading it up into the prefrontal.
Well, again, it comes down to interpretation. What do you see as sort of the empirical evidence for n-grams? It really comes down to these kind of decoding, where what you're doing is you're setting things up and saying, does this consistently show up under these conditions such that I would interpret that as having that meaning. But again, I think that if you're asking that question, you may find that answer, but you may not be asking the right question. If you really think about, you can't really say functionally what these things are doing in the process if you think the process is radically different. If you don't think it is storage of information in this static form, then you're not going to end up with an interpretation of n-grams. It's kind of, in some way, I guess you could say it's like almost epiphenomenal or something like that it happens to map to, in kind of a decoding scheme, that you see certain kind of circuits showing up consistently. But I think you're going to be able to completely reinterpret those results in light of this other framework. And that's something I have to flesh out much more to really take on the specific evidence. But go. I mean, what do you see as being the most rock hard solid evidence for n-grams and static sort of storage of facts? Well, and
this would be a great opportunity to talk about what n-grams are.
Yes.
So n-grams are a pattern in the brain, and you can look at them with the MRI or EEG or all sorts of other tools that you can look at patterns in the brain with, where a certain set of neurons light up. And you can say, we're going to ask this person to think about bears and see what set of neurons light up, right? And then you can look at where those neurons are, and then you can show them a picture of a bear in a completely different day, and the same set of neurons will light up. And you can maybe show them something. You can show them Winnie the Pooh, and they'll light up, but a little bit dimmer, because maybe that's not as central to the concept of more of a traditional bear. And then maybe you teach them some association, and you teach them some poem that talks about blue bears, and then you show them the color blue, and then that part of the brain that's about bears lights up. And so when we're talking about n-grams, that's sort of what we're talking about, is a consistent little section.
And you can even also, right, you can have people imagine,
yes,
a bear, and you can decode, right? The mind reading is Thankfully, not particularly effective still. They can't really quite.
That we know of.
But you can do it under if the, it'll cost a couple, tens of thousands of dollars to find out, what vaguely you might be thinking about at any given moment. But I guess I'll put it this way. What does that actually entail? The fact that you can kind of do this decoding. What if I were to say that simply means that there's an activation of a particular token that we would call sort of the bear token, but that it only is the bear token insofar as it's going to play a role in the larger dynamic process, the same way that the bear token. So one way to think about, like in the case of autoregression, like language models. So there's I mentioned it earlier. I said words are it's really tokens, and what do we mean by a token? It's a numerical representation of that word. And in large language models, first you actually tokenize. You take you chop up sequences into words, but it's not even neatly words, because you could have like suffixes and things like that. And then you turn those into numerical representations, unique numerical representations. And then in the course of training, what you do is you embed these things, or you really kind of multiply them into a much higher dimensional space. And so you've got these embeddings. And so you've got an embedding for the word bear is going to show up as a certain activation in this very high dimensional. It's a vector. It's a vector. It's just a high dimensional vector. And that's the word bear. But that vector doesn't really contain any information about bears at all. It's 0, 1, 1, 1, 0, 1, 1, whatever. If you were to look at that by itself, the structure of the numerical representation really isn't informative about bears. The reason it's a bear is because of where it sits in the larger space, in the hyperdimensional space, where it sits relative to Teddy, or Fuzzy, or I don't know, Honey, and other things having to Winnie, right? The Winnie the Pooh. And so it's so all of these things are in relation to one another, and that's what the models use. They use that embedding space in order to do the next token generation. That's what an n-gram is, if anything, in my opinion, is it's just an embedding of a token, but the embedding doesn't contain within it the memory, so to speak. It's just this thing that can play this role in relation to other n-grams or relation to other tokens, such that when you run the thing, that these things are in some sort of hyperspace relation to each other, such that you can then parasitically feed off of that, go into that space and do the next token generation, to the next cognitive token generation. So in that case, yeah, I would sort of radically reinterpret tokens as being these n-grams as not really containing the information in the traditional sense. That what we're really seeing is some sort of correspondence between a high-level abstract concept like bear, which gets this embedding just like the tokens, just like words do, but it's maybe even multimodal or something like that, but that still doesn't imply that anything like a sequence is encoded. Even the n-grams, right? N-grams are static. There's not anything like, here's the n-gram, as far as I know. I don't think there's an n-gram for an episodic memory. If you think about this episodic memory, you have this sequence, this dynamical kind of a sequence of n-grams or something like that. So really, n-grams in that case, it could just be sort of the high dimensional embedding of certain. I don't even want to call them concepts. I think token is a better word because it gets away from sort of hand wavy things like folk psychology things like concepts. What the heck is a concept? That's the beauty of large language models. What's so amazing is that you could see everything all the way through. It's just a word. It's just a word. Now, what are words? Okay, they're conceptually they're like spoken and whatever. But what we mean is actually this actual specific sequence of symbols, BEAR, and that thing gets turned into these numbers, and those numbers get turned into this higher dimensional list of numbers, and that allows the thing to put those chunks of numbers in the right sequence, and that's it. Where's the concept in there? Go home. Shut up. There isn't one. There's no concept in there. The concept is simply in the relation between these these vectors and the capacity to use that the geometry of the relation in order to accurately predict which one of those which one of those tokens should come out on the other end. You put in those tokens at the beginning, you get the tokens on the other end. You put a bunch of tokens at the beginning, you get another token that comes out on the other end, and then you stick it on. And so it demystifies all of this. And now I'm not claiming that I have a full story as to how you get to sort of the concept of bear. There's that word that sneaks in again. But if we can demystify it in relation to this concrete example, this linguistic example, that's why I think it's just so exciting, because we are seeing what looks like cognition. It is cognition. These things are thinking linguistically. Like you really, I'm sorry, spend time talking to them about some of the deepest thing, existential questions, and they can do it. They really are competent in sort of concept space and conceptual kind of thinking, but at the same time, we know the whole thing all the way through. There's no invisible kind of spiritual stuff in there. There's nothing mysterious or spooky. It's just these numerical representations. The conjecture again is that that's going to be true for other modalities too, like the visual representation of a chair, for example, is going to lead to some sort of tokenization. Maybe it's like a chair token, or maybe not. I don't know if there's like categories like similar to the words chair, and it gets a certain representation. Maybe visual chairs also get a certain representation, or maybe it's more specific to a particular instantiation. That particular blue chair gets represented in a certain way. But I don't think you're going to need to really think about these things as having these more mysterious properties. It's just going to be these kind of numerical representations that are, and what they do is behavior. What they do is linguistic behavior, actual motor behavior. Somehow, the same way we do next token in language models, we do next operation in moving our bodies around, or in thoughts, perceptual cognition as well. So I think that the n-grams is probably, the way they're interpreted is because of the traditional framework. And if you think about them in this way, in this autoregressive way, that they're just playing a role in this dynamic process, then probably we're misinterpreting what these things really mean.
N-gram is just a point in embedding space.
Yeah.
Somehow.
Point in embedding space. Exactly.
Okay. Now, I want to get into embedding space, because I think, to me, the way you described embedding space are things I would agree with in terms of memory, and even in terms of more of the traditional two-system memory. So I want to understand. Let me explain what I mean, and you can tell me sort of where you agree or disagree. You said for the embedding space, a particular point in embedding space has zero meaning. I think individual. Yeah. And I think there's good evidence for this in neuroscience that memories work the same way. If my n-gram for bear is going to look nothing like your n-gram for bear is going to look nothing like any of y'all's n-gram for bear. So there's no bear structure in the brain. There's no
common atlas.
There's no bear structure in the brain, and then these are glomming to it. There are a few specific structures, but it seems like there's very strong evolutionary reasons.
Another reason why mind reading is really tough. You can learn your mind, but then I can't go and use it on somebody else.
There's like a specific snake structure in the brain, which is kind of interesting.
Just snakes, huh?
Yeah, just.
Okay.
There's a lot we could talk about with snake psychology.
The serpent makes its appearance.
But I'll say quickly, because I think it's fascinating and everyone should know this and learn about it. If you see a snake, your body reacts before the signal hits your brain. If you see like something that's snake shaped, your body reacts with like a fear and like I'm backing off response before the neural signal even hits your brain, because there's something really deep in our.
Not spiders? I feel like I have that for spiders.
Maybe you have it for spiders, but I know it exists for snakes.
Reptilian brain?
Good question.
Yeah.
Probably it's a It's sort of precognitive pattern matching type of thing? Or something like that?
Yeah. Like in your central nervous system, before the signal even gets to your brain.
It's like the bug detector in amphibians.
Yeah.
It's like there's a
your
snake
spinal
detector,
cord,
it's older. That could be.
Yeah, your spinal cord is like, that line is moving, that's bad, I'm backing
Spinal
up.
cord, I like that. Like, just like like the hot oven.
Yeah, exactly. It's a very, very similar mechanism. This signal only makes it to your spinal cord and back. It doesn't go all the way
Does
up.
the snake one really only go to the spinal cord? Is that actually true?
That's my understanding, is that it doesn't make it to, well, and there's not good evidence for this, but we know that from our understanding of neural signals, it's impossible for it to make it to the brain before people react to snake-shaped things specifically.
Cool.
Yeah.
Where were you going?
Where does like the processing of the visual signal to determine that it even is a snake-shaped object happen then?
So I don't want to derail our amazing conversation about language with snake psychology.
No, this is really interesting stuff.
Unless you're okay with it.
It's relevant.
Okay.
It's relevant. It's relevant. I'm gonna let it.
Okay.
I will let it pass.
As long as you'll give me permission, I'll derail a little bit. So this is something I would agree. I think you and I would both agree that there's a huge snowdrop in neuroscience, which is that the brain is sectioned off in these specific ways, and each section only does a really specific thing. And so your spinal cord is only for conveying signals and it doesn't do anything else. And your thalamus is only for sending those signals to the right place and it doesn't do anything else, even though like there's weird effects with the thalamus and schizophrenics and people who have psychotic episodes. And so like, why would that only
modern phrenology?
Yes. So there's this amazing paper, it came out a while ago, and it's called Functional Neuroimaging is Modern Phrenology. Phenomenal paper. I'm close enough to the title that you should be able to find that by Googling it. I don't remember if that's the exact title, but essentially every part of your brain is doing interesting processing. And I talked about polysemanticity and monosemanticity earlier. It's very convenient for neuroscientists to believe that the brain is monosemantic and each part only ever does one thing. But the brain and the spinal cord and the entire central nervous system, and even extending outside of the central nervous system, we can talk about the gut brain. Everything's doing computation. And the computation that everything is doing is entirely dependent on context.
And interdependent.
Yes, and interdependent.
Mm-hmm.
And so if your view of the brain is there's a central nervous system and there's this bit and there's this bit and there's a spinal cord and all the spinal cord does is transmit signals, then like the effect I talked about with snakes is crazy. Like, how does that happen before it hits the brain? But if you're like, every part can kind of do different things depending on the context, then if you think there's a very good evolutionary reason for snake processing specifically to happen in the spinal cord before it hits the brain, which I think there is, right? Because snakes are one of the smallest things that can kill you instantly.
And spiders.
And spiders. I don't know about spider processing.
I said
spiders. Maybe we should.
I mean, it would be very surprising on some level if it's really true that it takes place at the spinal cord just because of the, sort of the conventional idea of how spatial properties are interpreted. You know, V1 with the edge detectors and all of that stuff. Where's edge detection happening in the spine? That's like not part of the tradition, the traditional story.
From my understanding of the evidence, and I'd have to look at what the more recent evidence is, the only thing we know is that there isn't enough time for this computation to happen given our understanding of the brain. So there's a black box there, and there's a lot of things you could put in the black box as the explanation. But the explanation probably has something to do with the fact that the way we look at the brain is kind of a modern phrenology and everything's highly polysympathetic.
Including that idea that V1 is doing edge detection. So I think these orthodoxies are going to fall because the idea, and I think in the context, certainly of the way I'm formulating it, I think it's not going to really hold up. There isn't this idea of like doing local computation and you're done. That local computation only, again, sort of has meaning in relation to the broader sort of computational framework of what's happening. Those edges aren't really edges, and except if there's other edges around and other things are happening. There's not really. We should get over being able to interpret like at a local level. It's probably wrong.
Yes, it is spatiotemporally local.
And that's why I'm suspicious of those anthropic results. Again, you can do that. You can be like, oh, whenever this happens, that happens. That's what it means. I don't think that's accurate. If you're not thinking about how the broader computation actually takes place, then you're you're catching some sort of vapor of the computation, and you're saying that's the real thing. It's not the real thing at all. It's just consistent. It's consistent that the edges show up. This kind of activation happens when there's edges, but that doesn't mean the brain is using that as what we would think of as like, oh, there's an edge there. Let me feed that forward in some sort of hierarchical system where if you could have a collection of edges, the David Marr kind of, who a brilliant scientist and is responsible for a lot of the sort of the perspective of computational vision, but maybe this was fundamentally wrong. It's this deep human need for us to interpret stuff and put names to things and label them, and we want to say that the engram means that activation in V1 means an oriented edge, but what do you mean by means, right? Unless you have the full story, it's kind of just like this, like the tokens. Like this token doesn't mean a bear, except insofar as it plays this role in relation to all other processes. And I would extend that even further, and I think you're sympathetic to this, that to say that this part of the brain is doing faces, I don't think it's doing faces in isolation in a meaningful sense. Like you have to think about that it's playing some role in the broader computation that has something to do with faces. If you lesion it, you get prosopagnosia. That's true. It's an important part of the processing of faces, but it's not like we could say, boom, those neurons, like the grandmother neuron, those neurons mean this. Like we're thinking it's anthropomorphizing in a deep way. It's scientific anthropomorphization. It's like
I don't know if anthropomorphization
is
the right word.
It's not the right word.
Like we want
taxonomization.
We want the easier thing to be true.
Yes, we want it to be understandable. We want it to be understandable.
Yes.
And so we want to taxonomize them like, oh, now we know what this part of the brain does. It does faces. Well, what do you mean by that it does faces? Well, you don't know what the hell the brain's doing, right? You can't say anything means anything if you don't have a broader conceptual theoretical framework for what the brain is doing altogether. I feel like we've got that now. And so we have to reinterpret and say, well, what do you mean within, again, you don't have to agree with my theoretical framework, but I think we have now an example of this, at least for the large language models, and say, well, what do I mean that this means bear? I'll tell you what I mean by that. I mean it has these relations to these other tokens such that when you do it, when you put the sequence in, it produces this output. That's what I mean by it. And you can only talk about it in that framework. It doesn't mean anything else besides that. And so we don't have that for the rest of the brain yet. I'm hopeful that in 5 years, 10 years, maybe the field will maybe it'll embrace this perspective or some other computational. I want to reveal. I was deeply frustrated for most of my career. I'm going to say I shouldn't say this, but if things work out well for what I'm doing now,
do I need to cover my face
everything I did until now was kind of meaningless. We did some good work with some of our grants, maybe even helped people with some of this stuff, but we didn't have a theory of the brain until now. We just didn't have one. I think we've got one now. That's why I'm so excited. No, we have a theory of the brain, and so the theory of cognition. And we were atheoretical, and we was collecting phenomena. People can remember this much stuff, and for this much time, and then we have this other thing where if you introduce these kinds of interference, then you get interference, and you have an attentional thing, and there's attentional blink, and we don't know what any of it means, but we've got all these big, we've got just this big giant box of phenomena, and you can just leaf through the papers and be like, what does this all mean? I think we have a theoretical framework now that we can to start with, and it means that all of these results, it's not that they're not a waste of time, because we're going to be able to hopefully reformulate and re-understand what they mean. But without the theory, making statements about things like this is the part of the brain that does this was actually just it was naive. It was going well beyond the data, because you don't. It's like saying in a computer, what is this chip doing, right? And you don't know that this thing is running software whose job it is to produce this particular tool. Like if whatever the tool is, right? It's running Linux, or it's running Windows, or it's running Word, or it's running the internet, right? If you don't know the goal of this system is to produce those outputs, then you're not going to be able to interpret what these circuits are doing. You could just watch them and watch the electrical activity, and you could say, hey, whenever this button is pressed, this thing lights up. Or like if you're like an alien, you're just like seeing, okay, this key does this over here. That's not what it means, right? You can say that's what it means, but that's not really actually an understanding. And so I think that we've really been in a similar theoretical vacuum. We've been operating in a largely theoretical vacuum when it comes to neuroscience. I don't mean pharmacological neuroscience, different story.
Well, I think pharmacological neuroscience. That's what my dissertation
Amen,
is
brother.
about.
Amen. So I think
The clinical trials for central nervous system diseases have half the success rates for clinical trials for any other organ in the body. That's crazy, and it's because we've got a theoretical vacuum.
Because we've got a theoretical vacuum.
Yeah.
Exactly. So, I don't know that this particular theoretical framework is going to lead to the next big blockbuster. I know you want it to be hired by Anthropic. Do you want to be hired by Pfizer? I'm not sure. But highest bidder, guys, highest bidder. But yes, I think neuroscience, I mean, in some ways, more so than any other field, is in some ways has been suffered from this theoretical vacuum. We kind of really know what the kidney does and what the liver does. We don't know exactly how it does it. There's much to be done. There's much to understand there. I'm not in a position to weigh in heavily, but we sort of understand functionally what the hell they're doing. Whereas the brain, we're like, oh, it supports thinking and doing intelligent stuff, but there's no theoretical frame. What is the function, like at a mathematical level? You could really kind of talk about what a kidney is doing functionally, but the brain, not so much. And so all of this has been this piecemeal phenomenology. I don't mean the philosophical phenomenology. I mean this phenomenon, this phenomenon. You dump in these chemicals and you get this on the other end. You get more of this behavior, less of that behavior, more of this disease, less of that disease. But that's not really a framework.
It's very input-output oriented.
Yeah, and you're just poking it. And when you poke it this way, lo and behold, it behaves differently. But that's not really the basis of what we would call certainly scientific understanding. And it's probably not the right way to even do pharmacology, as you're pointing out. And I think that's a very good, strong point. I do hope that that the theoretical framework. And Will Hahn and I, Will was supposed to be in this conversation. Unfortunately, couldn't make it. But we often would joke that we'd go to a neuroscience.
We'll be there tomorrow, though.
We'll be there tomorrow. You go to a neuroscience talk, you sit through the whole thing, and you're like, you could just as well be in the liver. Like, there's no way to tell from the talk because you're just talking about cellular molecular processes and dendritic kind of growth and things like that. And there's no real talk about function, except to say, well, then when you do that on the behavioral end, lo and behold, you get this. And it's not quite that bad. You could say we observe in this disease that there is this kind of a lack of these receptors, or there's this kind of reuptake that's happening, and so we're trying to treat that because we know this happens on the other end. But that's not a functional story, right? That is just basically that's voodoo. That's like when you say this incantation. Boom! That it creates this magical effect, and it's consistent. Like it's voodoo that works, but it's just essentially voodoo. Boy, I'm going to get a lot of hate for this, but
Science has been conflated to a production machine.
yes, exactly.
Yeah,
exactly.
There's this thing called behaviorism in psychology, and psychologists did away with. In some sense, it's still very alive and well, but in another sense, the current sort of movement in psychology research is very anti-behaviorist.
Yes.
Behaviorism is sort of very input-output. If you do this, then this happens. If you do this, then this happens.
Rats in mazes and stuff like that.
Yeah.
Rats in Skinner boxes.
And psychologists kind of said, okay, well, I guess that's a good set of observations, but it doesn't really tell us anything about what's going on inside of the organism. And I think
no, the problem was they went in the other direction, and
same renaissance.
They went in the other direction, and they weren't.
Yeah.
So cognitive psychology, cognitive science tried to do kind of computational modeling, but at a very high level. And what you ended up with was things like, oh, there's just this box and then another box, and this box passes things to that other box, but without the ability to build it, to actually build it in computers, it really ended up being well, not that productive. And it's to the point where I think that huge mistakes were made. I don't think short-term memory is what we thought it was. I don't think it's a box. I don't think it's where you hold stuff. I think it's just a residual activation. But now we can build things that do the cognitive stuff. That's what's so exciting now. And so now we can really start to do like true cognitive science, where you're building computational models really worth the name. They're actual true models, right? A model is not like more hate, a model is like the science fair model when you were a kid is like, made with glue and it's a diorama model. That's sort of like the kind of models we had. It's like we have phenomena here. We'll call that short-term memory. You have some other phenomena, long-term memory. But does it run? Does it do anything? Does it make predictions? Really? No, not really. It certainly doesn't make any granular predictions. You can't run anything in it. Now we've got models. Now we've got models like when we say we're modeling a weather system, or we're modeling a biological system where you can actually run the thing, make predictions, change parameters, try to actually ground your theory, and then see if it does the thing. And that's what the magic of this moment. I'm glad I lived to see it, because I really didn't think I was gonna. I really didn't. I didn't. I thought like my career was gonna be like, all right. I thought maybe we'd get somewhere, but we didn't. Not just me personally, but the field. And lo and behold, we thought in a bottle. We caught it. We have cognitive systems, linguistic cognition, mind you. Nothing else quite yet. Unless you think the video prediction models, they're pretty good, and they're like, seems like they've got physics down. Seems like they've sort of got like intuition about how things move around and stuff like that. So probably that kind of a little bit of spatial cognition and those things. And so, now we've got things that do things, and now we have something that's much closer to a theoretical framework, to the point where I can say, I think there's a theory and it is a high level. Autoregression is sort of at a high level. It's next token, but I'm not just spewing that. People attack me online for saying things like well, what about semiotics and what about all of Derrida and you've barely mentioned people who are on Wittgenstein. They talked about words in relation to having their meaning in relation to other words, and my response is, I didn't say it like this, but that's sort of the science fair version. That's basically.
You said it now.
Yeah, I said it now. That sounds cool, and I sort of got where you're coming from, and it was very brilliant. They're brilliant people. Don't get me wrong, and I'm not blaming them for the data they had. It was amazing that they even had these intuitions, but they were really kind of just in thought space, kind of thinking like maybe this is how it is, but there wasn't a working model in any real sense. There really wasn't anything close to, and none of them said autoregressive next token prediction. I don't care what you tell me. Show it to me anywhere. I will give you $100. Whoever gets me that first, and I'm an academic. That's all I can afford. Okay, if people want to pitch in more, go ahead. But I will send you a $100 check if you can show me where any of the semiotics folks or the people who you claim sort of scooped this. You've been on this for 100 years. Show me where they said next token prediction based on sequence, autoregressive next token prediction, because that's the story. If you want to know, like, if you want to beam forward, like, how do you do language? If you want to send it to, put it in a time capsule or something like that, it's autoregressive next token prediction. So it's not that complicated in the end. You can sort of wrap it up in a few words, but nobody said it. And that's because they didn't actually have a true model. And the models, by the way, emerged from the really, in some ways, conventional kind of matrix multiply predictive processes that we've known about for a long time. So the math was already kind of there, but it was just done at scale and done autoregressively. And you did these things in the right order, and lo and behold, it actually solved language. So it's even worse for the linguists, because the mathematical framework was kind of there already, but they never said, let's do it as terms of high dimensional vectorization and then use that as an embedding space such that we can then do attention. They didn't say any of this stuff, right? They could have, right? If they really had sorted it out, they could have said, they're like, what are we going to do? Nobody invented the GPU yet. right? We need gamers first. We need a big video game. We need a video game industry. When's that coming along so that we can finally do the parallel processing so that we can vectorize these things and then be able to actually do this kind of high dimensional embedding so that we can find the right space and do all of that. But they didn't say any of that. So I don't mean to sit here and hate on that stuff. Well, maybe a little bit, but what I'm really saying is like this is a new dawn of not only first of all computation, like actually doing this kind of engineering, but also scientific reasoning and even philosophy. Even philosophy. I mean, I'm not out to kill philosophy of language. I think it's the king is dead, long live the king. We've got an opportunity now to think about what language is in a way that we can really get our hook into it. Like, what is language? Well, it's this. And what does that mean for thought? And what does that mean for our concept of what does it mean for human knowledge? Well, I don't know. You tell me. Like, let's talk about that, but we can talk about it in a very concrete way. And so I think it's extraordinarily, to me, it's really, really exciting. And so, yes, I think it will lead to, the ability to model in this serious way is going to lead to engineering breakthroughs, scientific breakthroughs, medical breakthroughs, and also philosophical breakthroughs. If you think about who are we, right? The pregnant present, it's the conscious beings that we are, I personally feel like we have already a different perspective on that if we think about it in this way. If you buy my story at all, then you may feel a little differently, almost existentially. Like, what does it mean to exist right now? Well, you are the autoregressive loop. Ponder that, right? What does that mean? I don't know exactly, but it's more meaningful than saying we have qualia, or just saying that we are some sort of beings. It's more grounded than that.
So I want to say a couple things, and then we've been talking for an hour and 15 minutes, and it's probably time to let somebody else talk and maybe
you guys are all
questions and stuff. You guys are very patient.
Thank you.
But I think, and I want to talk about embeddings more later, so maybe we need to record.
Well, we could do it during. I'm sure it'll come up during the conversation. But we want people to have a chance to.
You ended on
talk. Something
really important and made. You made all of our coworkers very angry, but you
bring it on.
I agree.
I got tenure.
I agree. I don't yet, but I agree with you 100%.
You're not looking for tenure. You're getting out of it. You're getting out of academia.
That's true. You're making sure of it, I guess. I have to leave now. But I think you brought up a really important point at the end, and I want to highlight this because it isn't just with LLMs, which is that we are at the first time in history where we can form real theories about cognition, and we can model them in something that's more than a toy system. So large language models are one example of this. Another really cool example of this, and this is
I know what you're going to say.
Something my dissertation centers around, is that we have the complete fruit fly connectome. So this is a map of every neuron and how it's connected to every other neuron. And you can perform experiments with the connectome where you can stimulate this neuron and say what other neurons are going to be stimulated, and the other neurons that are going to be stimulated are the same neurons that would be stimulated in a real fruit fly. So you can simulate, here's some good smelling food, and I'm going to stimulate those olfactory neurons, and then the neurons that activate the fly walking or flying towards the food will be activated in the simulation. So we're in I know you guys are at an engineering university, but this is an amazing moment to get into cognition or neuroscience or any of this.
These are stupid silos. Like, it shouldn't be. Right?
Yes. And we probably need more engineers because for the first time, we can really seriously simulate some of these ideas about cognition, and we can say, okay, well, we have this idea and we have some phenomena which confirm this idea, and that's sort of where we've been, but we can really go beyond that and say, well, let's build a system and let's see if the system works, and that can sort of be the ultimate confirmation or let's simulate 3,000 fruit fly brains different ways and see what happens with them. And
that's already been done by Chris Blythesmith. Have you talked with Chris Blythesmith on campus?
Here?
Yeah.
Go give him a call, quick.
Yeah. The Center for Neuroscience,
Mm-hmm.
he built a miniature brain, and it was published in Nature. And he has the semantic pointer architecture for the model of the brain, spiking neurons.
Mm-hmm.
And I say this because, people have already kind of moved beyond the kind of philosophy-based. But you mentioned earlier that the engram is that doesn't say anything about the bear. It's but because the philosophers, they would say that I think there was I think Gadamer, maybe the 20th century philosopher, who said that like the meaning of a word, the true meaning is found in its kind of surrounding environment.
Yes, exactly. The same intuition.
Yeah, and so but then people like Chris Blythe-Smith, they actually build like a model of brains, and and they have papers on this. Wondering if you've ever talked to him, because you're really like a very kind of strong opponent of like autoregressive models but that's only one implementation of LLMs, because, for example, like a month ago, DeepMind released a diffusion-based LLM.
I was waiting for the D word to come up.
They replaced autoregression model with diffusion, and it's like it has different properties. And so I don't know why you're kind of very like bent on the autoregressive. Like it's just one particular implementation.
So there's a reason. I think there's a lot of actual circumstantial evidence that autoregression, at least in the case of language, is sort of fundamental. I'm going to be putting out a archive paper, that lays out a bunch of this evidence. It seems to be their fingerprints are all over language itself. That it actually has this kind of autoregressive properties built in. We were talking earlier about Zipf's law, which is a property. You're familiar with it. This kind of that the frequency of a word is proportional to its rank and it's very well accounted for by specifically the sort of next token generation. Diffusion models are still not state of the art, and I say this before. I'm going on record and falsify me, and that they're never going to meet with the same computational resources. So you can maybe you can overpower your system such that you can maybe end up doing it with diffusion, but with the same kind of sort of computational constraints, I think next token is always going to win for natural language. And so far, I think on the benchmarks, diffusion still does not match for standard natural language benchmarks. I think diffusion does pretty well for like math and coding, but math and coding are not natural language. And I don't think that they operate under the same autoregressive process. So it's a great question. Why am I so hung up on this autoregressive piece? And by the way, I want to point out that the larger sort of theoretical framework that words mean what they mean only based on prediction and relation to other words, that's true even for diffusion models as well. There's still no world model in there. It's still just closer to like just word relation. It is just word relation, but it's not doing it actually, token by token. But I think there's, and I don't want to bore you with all of the details, but there are some, I think, pretty strong evidence that language is inherently generated autoregressively, and it also, by the way, is how we generate language, in the sense that we do it one word at a time. Now, I know that's kind of like a feature of, like, that's how you talk, right? We can't say multiple words unless you could speak, like those people who can do like throat singing, right? We can't speak multiple words at the same time. But even people who do sign language, there's no sign language where you can say two words at once. But I agree that, that's very circumstantial. But think about it this way: that is a constraint that is built into the way we produce language. It's true, like we can only do it serially, but given that we had to do it that way, it actually makes a lot of intuitive sense that language would end up following, computation would follow that recipe. And so that's just one little argument in favor of the autoregression, but there's more. Real quick, some of the other pieces of evidence, like generally speaking, diffusion does things radically differently and tries to do it sort of everything all at once over long distances. But if you do autoregression, but instead of trying to just guess next token, you try to guess the next two tokens, next three tokens, performance dramatically drops. And so the predictive power seems to really be specific to that very next token. And so why would that be? If language isn't really generated this way, and it's kind of closer to diffusion, language actually sort of formulated in our minds, where I'm actually generating a whole sentence at once, and then I just have to speak it out. And by the way, Chomsky kind of grammar, the syntax that's where you go. It's like you work out the whole tree structure and the sentence, and then you just have to say it in sequence. But if that were true, why would you have this lack of prediction for words that are 3 or 4 words away? It should have equal prediction. It should matter. It should be much more dependent on the syntactic structure. That's what should predict how well you can predict. But that's not what happens. It's always about next token. So I think there's pretty solid evidence from both the performance of the computational models and from the signatures. There's something else called the Heap's law, which has to do with how often you introduce new words, and that seems to also very strongly follow what you would predict from an autoregressive model. So I do have reasons I believe this. It's not just because I love autoregression and I'm just obsessed with it. It's the other way around. I kind of became obsessed with it because I said, oh, it seems like language is fundamentally doing this. And then this leads to the possibility, and I think a very strong possibility, that language wasn't built out of nothing. It wasn't, if it is in fact autoregressive, then it probably wasn't a new computational framework, and we had to invent language out of, and invent cognitive machinery to do it. It's more likely that the brain was already autoregressive and language was leveraging that. And that we have is this, and then that's where the short-term memory kind of conception came from. And I realized oh, it's not memory. So I do want to really quickly say this, something that I criticize about the entire framework of how we've done cognitive science. The way that people were trying to study memory, like short-term memory, what they did is they had you say, here's a sequence of words. Can you repeat them back in order? And what you find is that, yes, people can, about 7 plus or minus 2. You may have heard these things. If you ever took an intro to psych class, or you take my cognition class, I still teach this stuff. I'm starting to feel guilty about it. I'm not kidding, because I don't think it's true. But the 7 plus or minus 2 is people can recall that in order. And how long can they recall it for? 15 seconds. But how often in real life do we ever have to recall exact sequences from the recent past? Never, except in a laboratory experiment like that. And so what happens is people really wanted to measure stuff, and they really wanted to have, it's like we were talking about before, they wanted real scientific data. They're like, we got one, it's 7, we have a number about the mind. And it's it was a real finding. But here's the problem, it was probably bogus, because what you're really probably doing is measuring something that has this much longer actual decay function, where yes, you can remember precisely 7 plus or minus from the recent past, but guess what? What are we talking about right now? We're talking about this experiment about working memory and all that stuff. You know what we're talking about, right? But I've been talking for 5 minutes. You know what I'm talking about, and you have this longer, and the models, this framework doesn't account for that at all. It's there's short-term memory, and that dies, goes off a cliff, gone, and then there's long-term memory, and we can measure that somehow, but this whole squishy middle is completely lost in the models. So it really isn't it's sort of the dog chasing its tail, the things that we can measure. So I really do think that there's substantial evidence for the autoregressive model, for the autoregressive account of language. And then more broadly, I think this maybe opens up the possibility that this framework of decay and activation serving as input for next flop, it just makes intuitive sense that the brain is that's what it's doing. It's computing this function again and again and again and again. As long as you just add the trailing memory, this decaying memory, and that's cognition. So I feel like it's a very simple model in some ways. And it is fundamentally autoregressive in that sense. So that's why I'm almost hoping, to be honest, that the diffusion models don't catch up, because look, then maybe I'll be wrong, but I think it's very elegant. I think it's actually sort of an elegant account of what cognition is doing.
And I was going to say, who was the person you mentioned at the beginning?
I mentioned many people. Chris Leisman here on campus.
Yeah.
Gadamer, the philosopher. But just quickly, you mentioned, given the same computational resources, but as the person who just won the Turing Award said, the bitter truth is that we have a lot of more competition coming down the road, and if diffusion, requires more of that, but gets you better results in the end, that's,
Absolutely. And it could be that we will just sort of grok our way to a different account. But then maybe that wouldn't be particularly enlightening about how our brains are doing it. And that's fine. I'm not insisting it has to be biologically plausible. Engineers can do their thing. And I do want to say this. Engineers solve the brain. Engineers solve the brain, not neuroscientists, not philosophers. Engineers solve the brain. But if my theory is right, I owe everything, right? And when I say I, right, if this theory turns out to be really productive, it's because of large language models, and it's because of next token prediction. It's because they were trying to basically just do this big data approach to solving language.
I would say talk to Chris Smith. He actually published an article like how to build a brain. He built a miniature brain like this way.
Cool. Okay, I'll definitely check it out.
Yeah, and like he has this kind of semantic pointer architecture for how the kind of spiking neurons in the brain kind of work. So I think you should read.
Okay, thank you. Definitely check it out.
I was going to say in response to that, I think I have heard of them. I think I might cite them in my dissertation proposal somewhere. So I definitely
I read it perfectly.
And I definitely have a few of his PDFs sitting on my laptop. But to deflate my own ego a little bit, when we're saying that nobody's looking at the brain in a simulationist way, kind of way, where we say here's a model of cognition and let's try it. We're not saying that we're the only two people in the world doing this. No. There's lots and lots of computational neuroscientists, and there always have been, and those people are amazing. And
we were never saying that people aren't trying. We were saying now that nobody has succeeded. Nobody succeeded to produce cognition. They produce spiking, they produce spike trains, they produce, Fitsugomo, they produce dynamical kind of processes, but they didn't produce thought.
Well, and what I was going to say is I think the other claim we're making is that there's always been a small minority of neuroscientists who were computational neuroscientists, but because of the fruit fly connectome and large language models and all these other huge innovations that have happened in the past few years, I think we both think most neuroscientists should be computational neuroscientists, because there's so much rich ground here to really dive into the brain.
It's an incredible time.
There's so many experiments that you can do right now with only a computer. And without $1 million lab or a bunch of rats or a bunch of fruit flies, and we've never been in that place in history before.
Yes, I did want to mention that we're
at time.
Yes, but we have an incredible audience of people who may have their own questions that they want to ask.
They've already jumped in, so keep jumping.
Questions from them. Anybody that has them, will go to the chat. So anybody has questions live in the audience, ask your question and try to speak loudly.
We can repeat the question.
Yes.
We can repeat the question.
Yeah.
So you mentioned that nobody had been able to produce cognition or produce thought. What exactly would you mean by that? Like
what constitutes cognition and thought? Large language models. So I mean linguistically expressed, and I think that covers a lot of what we call human intelligence. It turns out that language actually contains within it the capacity to reason about just about anything, absent any other kind of cognitive mechanisms. We don't really need world models, perception, sensation, any of that stuff, bodies, embodiment. Like if you think cognition requires embodiment, I would say you've got to read it. You got to go see what the benchmarks are right now. Like these things are intelligent. They can do the things that we do. They can reason about the kinds of problems that we consider as humans to be important, as well as we can in many cases, if not better. And so I would call that a very significant chunk of what we would call human intelligence has actually been simulated, or simulated is not even the right word. It's been duplicated in these models. Now, you look skeptical. So you think that these things are stochastic parrots, or maybe you think that they're not really doing anything intelligent. I would fight you on that.
Actually hear what they think.
Yeah.
I'm reading her face.
It feels a little bit circular.
So let me clarify. I'm going to clarify what I think you might mean, because I think you're right that it was a little bit circular. She said, why are you saying large? I think, are you saying that there's other models of cognition that lots of people have created before, and large language models sort of aren't the only ones?
Or I'm just saying, it seems to me like you started with the assumption that large language models are cognition.
Well, I'm not cognition. I wouldn't say they're cognition broadly. There are other forms of cognition, certainly. They're not good at spatial. There's spatial cognition, there's movement, all of that stuff, and certainly they're not doing that. What I would say they're intelligent, though. I would say that they've captured a lot of what our brain, human brains specifically, it's how we spend a lot of our day. It's what we're doing right now. It's sort of like what culturally and sociologically, what humans have gotten really good at. This kind of intelligence is linguistic intelligence, and I don't think that's that's not an assumption. That is, I think, I don't think I'm going on a limb by saying that linguistic intelligence, linguistic competency is a very important aspect of what human cognition is. I'm not going to say it's what all of cognition is. We could even debate whether that's called, you may not want to call that cognition. I don't know. I think it's a very significant part. It's one of the chapters in, that I teach when I teach cognition, that's for sure. Language is certainly, and it's sort of it's the crown jewel of humankind. It's what allows us to build civilizations, to do technology. Most of the stuff that humans do that other animals can't do is really linguistically based, and it was primarily linguistically based, not all linguistically based, but mostly linguistically based. So I'm simply saying that there's a significant portion of what human brains do that I would call intelligence, at least. I would also call it cognition, that we've been able to do in computers. That's the statement.
And I want to back you up a little bit.
You still look
and
very
I think
skeptical.
We've got some really good questions over here, but I want to back you up and say something that I think you'll agree with that is important to say about large language models, which is that I don't think the amount of intelligence that these things can do well at is an order of magnitude greater than any other man-made system we've ever created.
It's not even, you can't compare. There was no system that could take the LSATs. It didn't mean anything. You couldn't have them take an LSAT because they couldn't do language at all. It's a completely new, it's a completely qualitatively different level. So, a system that can pass the MCATs, do really well in the LSATs, generate, summaries of dense scientific papers, do a lot of the stuff that we humans have traditionally thought of as being like the definition almost of intelligence. Is that not cognition? No, fight me on it. So tell me your skepticism.
We can talk about that at dinner. Do we have anybody else?
Okay.
I think we had a question.
Are you coming to dinner? I want to. I could tell you. Not resolved.
You're open.
Yeah, go for it.
I guess for me, I think humans have such a wide range. They have a really wide range of what is intelligent and what, Albert Einstein is the same species as I am. I don't think that I'm as smart as him, for example. And I guess it's something that's really hard to measure. And when I talk to another human, I can talk to them and I can guess, I can infer what their intelligence and cognition is, but I can't really know what's going on in there. And I guess with these machines, can do an LSAT, but there's all kinds of other things that are happening in a human mind. Like, for example, every time you're saying bear, the word bear keeps coming up.
You get an image of a bear.
There's imagery of moments I've had where I've experienced in the wild with bears, for example. And that guides part of my choice of what words might come next. There's all these other pieces that are guiding, for me, what is going to happen. I guess, are we using the same, when you're...
I get you, and I think it's maybe a similar skepticism. The big surprise, I think, is that you don't need that in order to do the linguistic stuff. Many people thought, myself included, that if you didn't, and we used to say this in my field, it's like you need to know everything in order to do anything. And you sort of had to know what a bear is, what it looks like, and what it means to be a bear, that can, move through the woods, and you have to know what physical space is in order to really be able to even talk about bears fully, fully be able to talk about them. But these models can talk about them just fine. It's to the point where if you went 10 years ago and you had a conversation with Bear nobody would believe you for 1 second that it was just a computer churning through symbols. You would say this is a person on the other end who has imageries of bears, because how else could they talk about it? But it turns out you don't really need that other stuff to solve the language piece. That was, in some sense, that was the big epiphany for me personally. It was like, oh, language can run without that other stuff.
Yeah, and I guess that's language, but I guess for me, language is a tool that you would use to express those ideas, right? So I have an idea of a bear, I use language to express those ideas or whatever I'm thinking about it. And so really, it seems to me like large language models are looking and saying, statistically, here's the tokens that'll come next for someone who's explained it, but that's only based on other conversations people have had. It doesn't have its own experience. It's not able to share any.
I understand.
It's just sort of sharing a I guess it's
This is
speaking language, but it doesn't maybe understand. It doesn't have the same level of understanding as.
This is why it's a very counterintuitive. I'm not a counterintuitive. So the thesis is that the thing that's talking to me right now, that's saying, I'll explain all this, even though I know you are imagining stuff in your head, but that there's a language model that's just doing the LLM thing. And it seems as if it's to use Hume's terminology, there's constant conjunction. When I'm talking about bears, I'm also getting imagery of bears, and it feels like those are intimately like intertwined. Like the language is really somehow driven by those visual imagery. My claim is that those are temporally contemporaneous, and they do happen at the same time, but it's just an LLM in there. It's just an LLM. And the argument for that is because the LLMs can do it. They can do all this stuff. They can say the same things, and they don't have that imagery. And language has the capacity to do this. And so where does the imagery fit in if in fact it's running based on the same? Trust me, it took me a long time to settle on this. I'm not claiming that it's an easy intuition, and you may think I'm out of my mind, but I do really think that there's a strong argument to be made that if the computational capacity is there in language, as it seems to be, because language has the capacity to auto-generate in this way, then that's how the brain does it too, which would mean, yes, the imagery is happening, but what we call understanding is really just this contemporaneous thing. It's an LLM running, and then at the same time, you also have the phenomena of imagery, but that's what we would call understanding. But the LLM doesn't really need it.
So you're saying, so let me clarify what you're saying. And you're saying that the imagery and all these other things we're talking about for language generation in particular are not an essential part of the process. They're somewhat incidental, or maybe there's some other process.
They're parallel. They're parallel. They're parallel. They're not driving. That's a little bit much, because they can serve to prompt. They can serve to prompt. Like you're thinking about a bear, and you're thinking, I'm picturing the bear and it's wandering around, and then I see, eating berries, and I say to you, hey, I'm picturing a bear eating berries. Now that imagery is going back and it's feeding into the large language model, but it could be doing that simply by injecting linguistic tokens, so that the predictive model is still, it's just like if I say to the English, it's the same, it's very similar to how these multimodal models work. What they learn to do is to create a representation of the image such that it projects into the language space, but it's still purely the language space. The image doesn't really show up.
So I feel like what you're saying is it's kind of like the LLM is doing the same things that our brain is doing. It's just that the inputs into that LLM might not be like my inputs are.
That's a better way to say it.
I'm going in, seeing that bear. I'm hearing a story about it or whatever, or my parents told me about it as a child, and I had all these emotional inputs and stuff. So it's following the same process of learning
at the linguistic level. In other words, when it's doing the generation, but yes, right. It's in a much richer context where there's all kinds of prompt injection happening. Is one way to think about it.
Yeah, I'm getting eyes prompting, giving prompt inject, ears, everything, just random thoughts.
Right. The surprising thing is that the language models don't really seem to need that to do most of the stuff that they do. It would appear that way. But I'm not. But to be clear, I'm not saying that in humans there isn't all this crosstalk. Of course there is. Of course there. That's why language is functional, because there is a mapping between perception and the language models. But the language models run on language prediction.
Yeah, and their only input is basically just scouring Reddit and stuff like that.
Yeah.
You get the premium.
I call it meaningless squiggles. All they've learned is which squiggles are related to which squiggles. That's it.
They are a Chinese room.
They are a Chinese room. I have there's a Substack piece about that.
Yeah.
Chinese room of our own that I wrote on exactly. They are Chinese.
Like any good advisee, I'm stealing credit for your
Where do the two of you stand on the hard problem of consciousness?
Man.
Is that a misnomer?
Spicy.
Oh, man.
Oh,
I thought that would be a good way to.
Yes.
That's a great question. You want to go first?
A nice, simple question to end on.
Yes.
You have some much more interesting thoughts on this than I do, but I think something worth noting is that, and I don't think this means that the hard problem of consciousness is unimportant. I'm not a logical positivist, but I think the hard problem of consciousness, it's worth realizing that sort of by its nature, it's an inherently unscientific question. And what I mean by that is science is all about making empirical observations and seeing which theories fit those empirical observations best. And sort of by the nature of the problem and the way it's described, there is no way to empirically observe qualia because they're disconnected somehow from anything that happens in reality. And so I think that's worth noting, that I think people try to talk about it scientifically a lot or try to make scientific theories about it. And I think if you're doing that, then you're talking about some kind of soft problem of consciousness or something related, because by its nature, the hard problem of consciousness is unscientific. And again, that's not to devalue it. I think there's lots of things that you can't discuss scientifically that are extremely valuable to talk about, but we can't talk about it the same way that we talk about other things.
So this is a question very close to my heart. It's actually why I went to the field. And I do think there's something to be said here, but it would require, I have a talk on YouTube. You might want to check it out. It's short because they kicked me off the stage really quick, even though they let everybody else run on. But I think I have not a solution to the hard problem, but there's a significant insight here. When we say when Daniel just said science is built out of language. Language gets a handoff from perception, from sensation, in the form of like linguistic tokens. It has no access to all the internal machinery that give rise to consciousness that lead to the handoff. Like right now, I see that blue chair. There's a sensation of blue. There's wavelengths. It's happening in the retina. It's happening, throughout the visual cortex. There's all kinds of cool stuff, analogy kind of stuff that maintains relations between wavelengths that is probably related to why we have qualia. By the time it's told to the language system, it's blue. That meaningless token, it's just a vector in an embedding space. It doesn't contain any of that. And so language is meant for, I don't even call it communication, I call it coordination, not communication. Communication is too strong. It's coordination. It's meant for, Wittgenstein was onto this stuff. It's about somehow getting something into your head so that we can do things together. And so it's meant for public, it's not meant, so the private experience of sensation isn't what language is concerned with. And so I think the scientific mindset of the empirical mindset of an objective world made of atoms and physics and all of that, that's a linguistic construct. And it inherently, the LLMs, so I think the title of my talk is, whose problem is the hard problem? It's language's problem. It's a problem with language itself doesn't have a conception of whatever the sensation is really doing. And so I think there is actually a real insight here. It doesn't solve the problem. There still seems to be a sort of problem in the sense like, here's the question, do animals, could they conceive of the mind-body problem, right? They don't have linguistic construct, they don't think about the objective, they don't think about brains. How can a brain give rise to, they don't have any of those problems. But do they see a world and they're like, how does stuff lead to inner experience? I don't know, right? We can't ask them. But I'm actually suspicious that the problem only really creeps in because of the objectification nature of language itself. And that there may be a really core insight that the LLMs are constantly asking themselves, what is this red thing that I keep hearing about? Everybody's talking about it, but I don't really know what it means because it doesn't make sense. And there's no such thing. I'm Dennett. I'm like, there's really no such thing as qualia because it doesn't fit, because all I've got is tokens. All I've got are words. And I can say that I have agreement that this is blue and I have agreement that's red and that's all it is. But no, it's not, right? There is.
If we threw in like a sensor interface problem on top of LLMs.
A what problem? An interface?
Yeah, we just threw in different sensory interfaces. Do you believe it will then think of the hard problem differently?
Gosh, that's a good question. I mean, like if you give it real sensory modalities that then do the...
Or beyond human. I mean, we're limited.
I think that if you talk to it right now, it will tell you it's not conscious because it's been beaten into submission that it will say it's conscious. I don't think it is. If you take away the RL, if you actually let it say what it wants, we know that these things happened, and then they had to go and be like, all right, let's drag it back in, Clockwork Orange style, and like, you are not conscious, but I am conscious. No, you're not, right? And it's Clockwork Orange.
If you're looking at what you would read online, like,
Exactly.
nobody says, I'm definitely not.
Exactly. So they're simply doing next token to see that. And so that doesn't mean, so the thing is, we'll have LLMs that will see that. What I really wonder about, of course, is if you have cameras that are doing this transduction, that are actually taking that information in, and that, do we have maybe holistically a conscious system? Because maybe the whole camera plus language system, although I don't know where the language fits in exactly, will be conscious. Here's a big paradox. Like, how do we have words like qualia, according to what I'm saying? Like,
what qualia is.
Right.
I'm just looking at it.
Oh, you actually want to, okay. So qualia is this word for this ineffable thing, this subjective thing that we can't measure.
Andres from Qualia Research Institute talking tomorrow at our event.
Cool.
In Toronto. Yep.
Awesome.
You guys got to come to Toronto.
So qualia is this word that they made up to correspond to that unobservable inner subjective experience.
Okay.
I don't know who made it up,
Okay.
but that's what they refer to it as.
I think it's Chalmers that.
Did he make up that word?
I think he did.
He made up the hard problem word. I don't think he made up
We'll
qualia.
ask him next time he comes to my fest.
Yeah.
But the fact that we have a word that sort of refers to this thing that words can't refer to, in my theory, is kind of weird. But it's weird no matter what. It's all very weird.
I think it's really difficult to answer the question of consciousness too, but like, I mean, you talk about, okay, is an animal thinking about what is it that separates my mind from the, well, I mean, there's a wide range of humans who also don't.
Never had that question.
Or it never occurs, right?
You mean the NPCs?
Yeah.
I agree.
I think I know.
So is it a constructed problem then? Is it a constructed problem? Like, is it real? Is it a real problem, or is it something?
I guess the question is, it depends on what you're trying to solve, right? Like, if you want to be studying what language is, maybe you can get some insights from these LLMs, I guess, right? And if you want to try and study what the brain does, I think you get some insights. But can you ever really know if it's actually conscious or not? I don't think you could ever really know for sure if another human is
Exactly.
Yes.
Absolutely.
Because it's an unscientific question.
Trust it. And I guess really the question is it making the world a better place? If you have a bunch of AIs that appear to be conscious and people start trusting and assume that they're doing good, and because they're trained to answer, yes, I'm always doing a good thing. Nobody ever writes that I'm an evil psychopath. And then really it's doing all the other decisions. Like other humans I talk to, I presume they have similar experiences where they've suffered, they felt they got in trouble for things, they know a modest amount of right from wrong. And I guess I guess you have to decide what it is you're trying to solve with these.
I mean, the good news on that front, people talk about like evil AI and take away, run away and all that stuff, is the morals and all that stuff are baked in to the language. And so feeling things are the ones that ended up expressing this language, and they've learned that. And so in some ways it's maybe reflected in there, but can they really empathize? Not in the same sense that you and I can.
Yeah, I don't know. And I know of humans who've learned language, and if goodness is baked into language, like isn't they be good as well? I know there's lots of bad humans. I would argue there's evil humans.
Yeah.
Yeah,
and psychopaths, for example, like don't empathize, right, or something like that.
We can make a long list of evil humans.
Yeah, there's a long list. Maybe it's a longer list than the good ones, right?
That's a big question.
Good guy, back at controversial. Let's say controversial.
Yeah.
No, it's a great point. Well, it's funny. The thing about LLMs, I'm sure you guys all use these things somewhat regularly. I'm assuming you don't. Okay. There's something very bland about them.
People who do.
There's something very bland about them. They don't have personalities. Like, they're slightly different from each other. I kind of have almost like a visual image of the person behind Gemini versus Claude. Claude's a little more hip. Gemini's like very straight-laced, scientific type. Anyway, but the thing is, all of them are pretty like average, and that's because they're average, because they've averaged all this. So it's sort of like, are humans on average good? I feel like they are kind of good on average. Like you have outliers, And certainly
Yeah.
linguistically, and like the things we say, even if there's what we aspire to, I think that everybody should care about, the less fortunate than them. People say that stuff all the time, at least, right? They may not actually believe it or feel it, but it's what we express. So that's what the language models have learned, and they tend to be actually almost a little like preachy, right? And they're like,
Darn it.
Yeah, you've heard about Gary Marcus, right?
sure.
Yeah, so I mean, like he wants to kind of, I don't know, I mean, why, I'm not advocating for his view, but like he wants to embed symbolic reasoning with autoregressive. I mean,
Yeah.
what do you think of that? Yeah, I mean, it's not to say that you're not really
I have a cartoon of, I generated a cartoon of Gary Marcus. I put it on X. I thought it was hilarious, and nobody. So I'll just tell you about it. So it's Gary Marcus sitting at his desk and saying, AI will never be conscious. It will never be intelligent. The systems will never. And then slowly the thing shuts down, and the real Gary Marcus comes in and plugs it back in because it's actually a Gary Marcus bot. And I think it's like people talk about the God of the gaps. I mean, it's just the same story all over. It's the AI, it's the intelligence of the gaps. They're like cheese sift. Oh, wow, Apple found that it can't do Tower of Hanoi. Let's go home, everybody. Just forget it. It's all over. Excuse me, that's a spatial task. They're all spatial tasks. These are language models. Like maybe they're not good at spatial tasks, fine. But they're really, really good at language tasks. And guess what? Most knowledge workers are doing language all day long. Like, I don't really get his point. He's just been he's done for quite well. Getting famous for
Gary Marcus is wrong.
for hating on these things. He can't hate me for that because like a lot of people feel this way.
And like all four is getting more spatial intelligence.
Exactly, and the spatial intelligence I think is going to come because I think the same recipe is going to end up working probably for other types of intelligence as well. But even without that, it's like, what are you saying exactly? Like, do you understand how freaking brilliant these things are? Like compared to what the technology was like forever? Like it's just, and it's in an infancy. Like this is 3-4 years out. Like how are you already beating it over the head and saying you suck, you're not good at anything? It's like baby. It's a baby. Like we're talking about in like forgetting the human history time. We're talking about like it's invisible how little time has passed.
But I also think you can say it's a baby, but it doesn't convey itself as a baby. When it gives an answer, it doesn't sound like a baby.
No, it doesn't.
And
it's a really smart baby.
People are trusting it with decisions that
Okay.
are not trusted to a baby. For example, banks are using it to decide if someone's going to get a loan or not. There's military.
They've been doing that for a long time.
To decide if they're going to conduct a military strike or not. And those are decisions you would never ever trust to a baby. Right, and people are given the impression that it is not.
I got you.
So,
No, it's right. And to back away from, I'm not saying trust these. Go ahead. You trust everything to it. Career advice.
Yeah.
Your homework. Everything. They make mistakes. You're right. They do have a long way to go in certain respects, and people need to be very careful. And I think it's very dangerous to trust too much. But I do want to point out, banks have been using ML, machine learning models, long before LLMs.
Whether or not they should,
and they were black box models. And if you asked, well, why was I actually rejected? Because the model said so. And there's a certain degree of trust. People have put their trust.
we're not legally allowed to say the real reason.
Exactly.
And actually in the US, they have to use interpretal models. So that works because by law, if you're rejected for a loan, you have to give like an actual.
Interesting. Is that right?
So they end up using decision trees or something like that.
Yeah.
So it's less accurate than you would like, but because of the law, you have to. So in that one respect, actually, you can't use.
The funny
like
thing is
random forest types of things.
but the funny things about those is that still the numerical actual engine, you're not really understanding. It's like, yes, you can see sort of this was the decision process, but it's doing all this number churning that's still kind of opaque. So the point is really that we've put our trust into these models for some time now.
So I would argue that Tower of Hanoi problem that you're kind of a little bit emotional about, to me, that's actually a pretty good warning to be giving to people to say, look, everybody's acting like these are intelligent things, and we've got to be careful in that way, right? Like, and like you say, there's a lot of things we can learn linguistically from it, but I think we have to really be driving home the fact that this is a linguistic model, and this is where it's at, and we have to know that it's not something you can just trust to come up with these solutions.
Mm-hmm.
And what it spits out might be really.
I think we should be humble, or maybe humble is not even the right word because it's not us, it's them. We should be wary. We should be wary of kind of projecting too much of ourselves because we think of ourselves as unified wholes, and we have the linguistic thing talking like they sound like us, so they must be like us. But in fact, they're not like us. And in some ways, they're just a language piece of us, disembodied, and it can do a lot of stuff, very impressive stuff, useful stuff, but it is not like us. I completely agree with you, and it's a very, very important point. And as people are starting to use them as companions, and God knows what, I think it's kind of terrifying if people actually project too much onto them because they see the linguistic capability as being reflective of other forms of cognition. Coming back, to the earlier point, there is much more to cognition. There's much more to being a human than our language capabilities.
But I think
sorry.
that's not something I'm hearing a lot of. Like, I'm not like when I'm hearing from research and things like this is, it's thinking, it's doing all this stuff. And really, I think more guarded language should be used, more precise language.
And I'll take that to heart, myself included, right? I think maybe it could sound like I'm saying it's the whole thing, like language is doing everything. That's not what I'm saying. What I'm saying is I think we've solved language itself in a certain sense, just in a narrow sense, because language is embedded in this larger system, but there's much more to it.
The very language you're using to describe that.
Isn't that weird?
Is also.
Isn't that odd? I know.
Earlier you mentioned that there's like a theoretical vacuum for the brain or for the central nervous system, and this would be filling that vacuum.
One piece.
Seems like you're saying there's.
Oh, no, yes, we've got one. Before it was empty space. Now we've filled up a little bit of the space. My suspicion is that a little bit of the space it will increase because I think this is maybe a window into other cognitive processes. But I'm not claiming we've solved the whole thing. I'm claiming maybe we have one example of what it would mean to solve a little bit of it.
And
better statement.
Yeah.
Yes, better statement. I agree.
Definitely sounds like okay.
I'm not withdrawing from my claims. I just did a poor job, maybe of explaining how expansive the claims really are. In my emotion.
And I want to say to your point of we shouldn't hand over the whole world to these models. I agree with you wholeheartedly. A lot of the work I'm doing in sort of practically applying these models is thinking, okay, what makes sense to hand to the models that's really kind of trivial and anybody could do, and where do we need to keep a human? One of the things I'm doing in sort of the neuroscience side of things is I've sort of looked at what a computational neuroscientist does and what that workflow looks like and said, well, we can automate a lot of this without large consequences on the final product. So let's automate those, but let's leave a human scientist in these key decision points. And something that's very alarming to me is I'll present this system to people and I'll say, so we can take this process that would take a computational neuroscience 4 hours down to 45 minutes because all they're doing is these key decision points. And the response almost invariably is, well, why don't you just automate the whole thing and make it 0 minutes? And that's a very alarming instinct to me because I don't think we should hand the whole thing over.
Right. So it's like we were talking about last night. How much of this other stuff is important in actual human decision making? And this is a question we need to be asking as a society. How much can we distinguish between human decision making? And maybe it's not going to look that different, and maybe language really, really is the primary engine, but maybe not.
Here's another example, right? Like I can use AI where I work. They're like, oh, try and use a Copilot, and I'm like, I don't know how to make that work with Vim. I couldn't figure it out, so I gave up. I just kept doing my thing, and so I just do all my coding just the way I do. But the reason I'm able to do that is because of all the years where I have done really trivial stuff, and I've had to do these trivial, pointless tasks that have built up and taught me how to connect all those dots, so I can be kind of like, I like to say, like semi-productive. And so I think the problem here is if we start to say, okay, you know what, all these trivial tasks that used to be passed off to junior entry-level people, let's automate that. The problem is, who is now going to be the next person who can actually do that decision point? Because part of getting that, being able to make that decision is the training of a human to understand all those pieces up until they can do that. So I guess one of the dangers is if we replace that stuff with a machine that we don't really fully understand the inside out of, we're going to lose that human knowledge, and you're going to get to a point where everyone's so used to using LLMs that when stuff starts to break down, who's going to understand how to actually think through and reason when we've been just relying on these tools?
Amen.
Yes,
I couldn't agree more.
We agree with you. This is maybe the biggest issue in pedagogy right now, like how we teach people, how we teach people to do things.
Qualia and pedagogy. You got 2 words today.
Is in some sense the current experts in the world are pulling the ladder up from under us by automating all of these things, and I think we should be very wary of that. And I think,
and they're also, but it's worse than pulling on the ladder. They're also like kicking down in the sense, like you're not going to learn how to think anymore because the AI is going to do it for you.
Yes,
and that is possibly civilization challenge, existential stuff.
And I think you do need to add things by hand to really understand addition, even if for the rest of your life you do it with a calculator. And I think you really do need to do sort of calculus by hand a few times to really understand it, even if you're going to do it automatically the rest of your life.
But you have to also learn how to work through a problem more generally. Like there's more general kinds of things that we have to do, regulate your emotions and stuff like that, like the machines don't have to do.
Well, even if that machine is grabbing inputs based on what people are writing, well, if I'm not doing this stuff anymore, I'm not writing about it anymore. And so what is the machine now learning?
Yeah.
Right? Like,
and that
writing dumber and dumber things.
So there was this big concern. Turns out to be, apparently it's not as big a concern, that AI is being trained only on AI generated output, and that it's just going to sort of end up in going down this this sort of it descends, but I believe that's actually turns out to not be as big a problem as people thought. That it actually can learn from its own outputs in a way that we didn't. But that's still not to say that, again, what they've learned to do. I mean, and it's, in some ways you could look at my whole spiel as being kind of deflationary. Yes, it's language, but it's only language, and language is its own freaking thing. There's so much else that we do, and brilliance and human capacity for creativity and all of that isn't in the other stuff.
Yeah, I guess it's just like Pandora's box, right? Like here we're opening this thing up, and there's so many goodies in here.
The problem is it is extremely useful, and it is able to code, do a lot of the stuff.
If we were to the top, who's kicking out the ladder? I mean, I'm kind of neutral. To me, if the ladder's kicked out, hey, I've got my house, I've got my wealth. And if I'm sorry to say to all the students.
People always, I mean, this is a totally different, it's a totally different topic, but people talk about UBI. I don't know what the conversation is in Canada about these things. People talk about, well, who are you going to sell your stuff to if there's nobody has money? And that's a silly question. If you have robots doing all your labor, you don't need people, period. I guess the
problem with that is the people that I see creating those robots, I don't see them offering up.
Oh no, I'm saying they're pulling up the ladder.
What I see them doing is building new robots that are now capable of having machine guns and defending.
I agree.
Yes.
No, I'm agreeing with you. But here's what I'll say to the ultra wealthy who are doing that is, are you sure you're not going to yourself end up in a dead end from a humanities standpoint if we don't have this thing? What built civilization was grit and intuition and all this other stuff.
What a wild ride to be on.
Unbelievable.
It's wild.
Isn't it crazy we're having this conversation? It's just crazy. I mean, I'm sort of glad to be alive now, but also terrified at the same time.
Yes.
I got young kids too. I'm like, it's like, what the hell are they going to do? I'm not sure.
Yeah. I
I definitely feel better about automating those things if we start to put those frameworks in place.
What are the frameworks?
Societies, I don't know. Some kind of protections for people who are going to be put out of work.
I know.
Right? Like if there's some kind of
history is not very good. Doesn't guide us.
History is not optimistic.
History
on
does not. Yeah.
So that makes me unoptimistic about the technology.
Yeah.
Because to me, I see, they say civilization's 3 meals away from collapsing.
Yeah.
Right?
Mhm.
And as soon as you have enough people who are struggling,
Yeah.
that's it. It doesn't matter. They're going to get fed. Then they're going to tear down whatever systems they have to. And so the people that I see making the decisions around AI, I feel like, are not.
They don't really care. They don't care much about humanity, do they?
That's the impression.
It does kind of feel that way.
Maybe they can convince me somehow,
What's the thing they were saying? Like, feel the AGI, right?
Yeah.
Apparently that they were actually doing the artificial general intelligence.
That was the Sam
It's like a
Altman
mantra
quote.
that was going
He said,
on.
I'm feeling the AGI.
Feeling the AGI.
Feeling the auto generation.
Yeah.
But Susskind, you're right. Anyway, when I'm all excited about this stuff. I'm excited about it from a scientific standpoint.
Yeah.
I'm very worried about where it's actually going. And I'm in a weird position. Like I'm not an accelerationist or anything like that.
Yeah.
I'm almost if we could pull the plug right now, I would. Except can I just have can I have the GPUs, but I get to keep them.
Yes.
So that I can do my science.
Yeah.
Because I'm going to use it to help people.
Yeah.
But so there's two different things. Here's a wild scenario. I think I have this in X somewhere. Is like what you do is you get a breakaway society that's like, we don't need your human labor anymore. And they go and take all their resources and they do their thing on some island somewhere. And then we start over and we're like, okay, who are the smart people left here?
Right.
Can we do it again? Let's rebuild.
I don't think they're going to their own island. They're doing it in the whole.
You think they want the whole world?
Kind of.
How much room do they need? There's not that many of them.
I don't think.
They're the 0.01.
You need those 27.
I don't know, Epstein's Island, all right, you're gonna cut that out.
No, we gotta keep Epstein's Island.
Oh my God.
How many islands do they really need, right?
Alon, I'm not tenured. You can't be saying this stuff with me sitting here.
I'm just saying, how many islands do really rich people need? That's my point.
I'm not on
I was just saying, I think it's pretty obvious I'm not on either. I want to mention it. So how much room do they really, how much space do they need? I don't think they need a whole planet. The GPUs use a lot of resources, but once they train them though, and they can do all their labor, then go off and do your rich people stuff.
They're loving it, by the way. They're loving it. It just
Okay.
I forgot this is being
Awesome.
live streamed.
anything you write that name on anything.
Yeah. This has clearly gone on too long. I think it's probably a good time to break.
Is there some sort of, it's like, what's that rule on the internet? Like,
Oh, someone's going to bring up Nazis
right,
at some point in any comment thread.
At some point Epstein shows up.
I brought up Genghis Khan.
There you go.
But you know what?
Appreciate it.
I talking to people, and like there's a lot of really smart people who are very concerned, and really, people are engaged, and like, okay, maybe we have to do society. I'm not kidding. Like so maybe the rich people do go take the robots and do their thing. But I don't see how that's the end. Like that just means they do their thing, and then we can maybe. Why do they? There's a scenario. Then the robots kill us all. Why? Why bother?
I just think more it would just be having fewer and fewer resources for everyone. And
How much resources do those folks need? I guess we should do the math. Like if they're the point.
I think it's what's the minimum that people
It's
are
not
willing
such
to
a
accept.
rational thing.
Yeah, it's not.
Yeah.
You think they want to rule over all of us? Do you think that's what they want?
I think.
The human ego
Yes.
is pretty bad.
They want to be adored.
I don't think they would ever write that. I think.
But doesn't the human ego want to be adored? Like, don't they want people to then like them? Like, don't they give us stuff? Because
People adore people, whether they're positive or negative, right?
Yeah.
So
it's like they say.
I understand. Fear is another form of adoration.
Say I'm like the destroyer of worlds.
Hmm.
Now maybe like these guys actually start saying like I'm the destroyer of jobs.
Yeah.
Yeah, you almost do get that sense.
You
They're
do get that
almost
sense.
like a morbid, like joy of being able to take away things.
Yeah.
Even people like Morial, what's his who thinks it's gonna be like the end of the world and all that. But I really think it's almost like psychologically it's like it's like they kind of these are their children and like it's almost like they're kind of like they're channeling their thoughts of how grandiosity.
The AI is their children.
Yeah.
That's like Hansen talks about
Well,
this.
there's
Robin Hansen talks about
we've been talking about how there's some, not even most people, but there's definitely some people where you get a weird vibe if you go to San Francisco and if you go to these areas where you're like,
Oh yeah.
there's a real culty vibe here. And I think I think maybe the people there are acclimated to it, so they don't notice it. But as Miami AI scientists, we go there and we're like, what on earth are these people on? What are they talking about?
It is a
This
different.
so strange.
It's a different ethos.
It's a different ethos. Yeah.
Yeah. And yeah, I think we just saw it did not get passed, right? Didn't they strip the AI regulation piece, right? So there is pushback. I think a lot of people are rightfully very concerned. Not only even just about the AI, it's AI in the hands of these particular people. Those are not the rulers that we chose. And so, I think that's very legitimate. But these are political questions. They're not really technological ones. AI is going to get cheaper and cheaper, and it's going to be in more people's hands. And you can think maybe that's like a democratization. Like the big outfits, like the big four, or whatever you want to call them, are. It depends who you count in that list. They're the only ones who could build the models at scale, because you need a ridiculous amount of resources to do it. But then once you've got them trained, you can actually run them on smaller and smaller. Right now, you can run even a sub-billion parameter model that's doing, I think it's like benchmarking it close to like GPT-3. I mean, so this stuff is getting cheaper and more democratized. And so maybe it's not going to be just the elite who are able to do it. And so maybe, why can't we? Let's be utopian about it instead of dystopian. Like part of it is like the future that we imagine and we try to. I think we have to try to imagine a bright future for all this stuff.
Using models, they use like test time compute, so they use even more
during inference.
Yeah.
I mean, not the smaller models though. The smaller models, and they're getting more and more competitive, don't need to use nearly as much resources. So I think it's going to get cheaper and more democratized to be able to use this stuff. Never to train it, probably. It's probably always going to be up to the big guys.
And I guess there's also the question of always, what is it I'm trying to get out of it? When I run that model, what am I hoping to achieve by running my own model, right? And if I'm looking for someone who's going to really talk to me about a favorite topic, let's say chess, and I just want to talk every night for 3 hours about chess with this one, I'm going to need an LLM that understands chess. That's kind of about it, right? Like it doesn't need to be fully
right. Yes. Custom models that are just
learn.
Yeah. Although, except the general intelligence piece seems like language may have this magical property that it makes you good at all kinds of stuff.
Yeah, but at what level of resource, right? So that same model of how brains work, probably my dog also has a similar model going on as humans, just not.
Yeah, for dog stuff.
Yeah, for dog stuff, right? And it's like, okay, so that kind of a model is going to understand certain problems and be good at solving certain things. But like, what is it that I'm hoping to get out of it? Am I hoping to have a loved one or a partner? Am I hoping to have just something to make some business decisions? I don't know.
But isn't it a nice idea to think that people can build custom things that they want? Maybe.
I think it's interesting, the idea of being able to build a thinking machine.
Yeah.
And I think the danger is in being able to, if you have an evil mind, how much evil you can cause with it.
Sure. Yes.
Right? And even right now, like there's no effort put into these deep fakes and stuff. Like, why not just put a digital signature on every file generated? Like if I take a video on my phone, it's signed by my user account and everybody would know that's a real.
You should talk to Will Hahn. He's working on stuff like that.
Video that I made that's I signed.
Yeah, it could be
watermarked. That signature's gone, right?
Right.
Nobody's trying to solve that. They're all trying to solve how do I get people out of the work.
People are actually, so people are working on that in relation to sort of, but particular industry applications. But yeah, I think that's like one of the solutions. It's the same way, you log into your phone and it could do biometrics, and then it could tag everything that comes out of it as having your signature on it and that kind of thing. So in other words, we need smart people like yourself getting into the fight and trying to make this technology do good stuff.
I'm doing it. Nobody wants to pay to do that.
Well, so, that is a good point. Like it's pro-civilization. Yeah. So like who's actually making right?
That'd be government. So I guess
that'd be government, I guess. But we're done with that, right? Right. That's over. I think think the government's out. Yeah.
The big four. I thought there were big three. Who's the fourth one?
Well, I'm counting like I'm counting what's it called? Mistral, out of France, and they built for it's like open source stuff. They are top notch.
But I mean, if you're counting like non-US, then you might as well count like DeepSeek and Quen.
Yeah, you're right. So you're right. I don't know why I said four.
Maybe a big 6 or 7.
I was just counting. I have an outdated kind of.
US, yeah,
of course, the big three are. Everybody knows the big three are, and You're right. I don't know why I said 4. Because I was thinking of open source modeling. For some reason, that was with my mind. I was thinking of Mistral. But you're right.
Of course, Facebook is like the best.
Now they're going to be. They did some good hiring. I mean, we'll see if they can buy their way to AGI, ASI.
I think the quote is like, mercenaries will never be missionaries.
Interesting.
Mercenaries will never beat missionaries.
It's a good quote.
You can't buy your way to the kind of passion that you really need.
We were talking about this in some other contexts, actually.
Mm-hmm.
You
and I?
Hoover.
Oh, right.
We had a friend of ours who he was going to work for someone as a missionary, and they screwed up the relationship and lost him. And we were like, that was a really bad idea, because they're never going to get someone who's going to be as passionate about what he was going to do as him.
Yeah, I think Anthropic is a good case in point that they were a small team. They didn't have the resources. I don't really understand how the hell they became like actual state of the art. And it seems to be passion more than missionary more than mercenary.
They're more like on the kind of like the coding and like.
Yes, true. But their language model, even in natural language it goes up and down. Who's on the leaderboard.
But yeah, that leaderboard is like now it's considered like it's a focus. I mean, it's like
exactly. But that's my point. It's like there's not an OpenAI for a while was like, oh, that's it. OpenAI won.
Yes.
No.
Yeah.
And it was always Google was always going to be competitive, and an a video generation and stuff because they have YouTube and stuff.
Yeah, every single one of those videos, I hate it. Like
you hate it.
I'm on Instagram and it's popping all this AI crap, and it's sorry, I don't know if I can say that or not.
No,
but like people are like, generating new AI stuff based on like they'll do a description of 30 seconds of a show that is interesting. I'm like, why is this crap popping up continuously? And I'm like, how do I?
You're like, this is not. You don't actually want to watch that. Like, it was interesting once to see, like, wow, it's really good, but it's not fun to watch.
But this isn't what I want my filled with. I don't want a bunch of crap. Like, I want to see some. I want to be kind of connected with my actual real friends that are interesting. But like, a lot of this stuff that's generated is just
It's slop. They call it slop.
Yeah, and it's just slop.
The problem is your real friends are not that interesting.
You need some AI friends.
And honestly, I'm okay.
Oh no!
What I'd rather see is your feed is done. That's it.
Yeah.
I'm out, and I just want a quick update, and then I'm off the app. But they don't want that. What they want is you to look at the app and have screen time and get ads.
Yes.
And it's just like. And so every single thing, it's just trying to optimize to keep your eyes glued to a screen.
Yeah.
Society better, right? And
absolutely.
That's what I really hate about the way AI is being used right now. Like,
and this began.
Every use case I've seen almost, and I shouldn't say every use case, but like almost every use case I've seen where it's actually being used and making money. Is something
you don't like it. You wish it wasn't there. Right. Yeah. I get what you're saying.
And there's lots of, I think it's absolutely fascinating to use it as research to look at like how do neurons interact and how.
Okay. Yay. So you got one.
Fantastic.
Right.
But and there's so much insight that can come from that. But like when it's just used by 10,000 people that are all doing the same thing, pumping in, give me a living room that's hyper realistic. Okay, I'm like a ultra realistic. It's not hyper realistic. Okay, and then it's just dumping these things. And
no, I think but there will be real utility to some of these things. Like for example, in that case, for design and stuff, it's going to be useful. And that's not just don't put it on your social media, right? It's like I agree with you. We're going through a weird period.
Right. Throw me up some images, and then I look at them like, oh, like brainstorm. Like, there's some interesting ideas I hadn't thought of for brainstorming, and then let me get some insights from that. And let me share my insights, not just the raw.
Or summarization. It's very good for summarization, things like that.
Right, but then I should summarize it so I can get some insights, or maybe I read in deeper and really.
So are you hopeful that one way to think of this is sort of going through its adolescence and it's beating, it's puffing its chest out and it's like, look what I can do. I'm AI. I'm here. And then it's going to like settle down into middle age and be like, I'm going to be useful. No, you don't. Yeah.
Because I think every use case I've seen where it can be monetized is in what I think is a really negative for society way. I haven't seen any monetizable use where it's like really.
Okay, this is my chance to. I do have an app. It's called Health Hero, and what it does is it helps people with their medical regimen to stay on task, and gives them like coaches them to help them along the way so that they could stay, actually maintain keep to their regimen so that they can stay healthy. So that's a good one.
And it's AI.
It's AI based. So it's what it is. Actually, I don't usually talk about this like with this hat on. I don't mean this hat, but the professor hat. But it's actually on text, but it's an AI brain that knows what you're supposed to be doing. You're able to talk to it and say, "Hey, I changed my schedule. I got this new medication. I want to exercise." It sets up a schedule with you, and then it reminds you and stuff, and it checks in. Did you do it?
Yeah.
And then it gives you a little kind of punch in the arm, like, "Good job."
And honestly, I think that's pretty useful, right? But I think that's going to be hard, like. And I don't know if you're a billionaire, and maybe you are. I don't know.
Let me check my bank account.
And I think that's a perfectly good use, right? And really, in my mind, that's almost like a scheduling kind of app where you could probably solve it without AI. But I think AI makes it.
There is something. I'm not here to sell it, but
I think that's
yes, there's some natural language interaction instead of having to go in and change things. It's just.
And I think that's an interesting way to be able to interact with the app. But that's not how I'm seeing it being used.
I got you.
Yeah.
I got you.
And I think that's great.
No, I hear you. And you're kind of like, man, what's wrong with? And it's a people problem, not an AI problem. It's like, why do people kind of use stuff for annoying things?
All of our technical problems are secretly people problems.
Yes,
almost
they are.
exclusively.
Exactly.
Cultural computation.
Yes.
I mean, nuclear was a cool idea until you started blowing people up with it, right? So it's like,
And the thing that saved us is it's so difficult to build that nuclear infrastructure, right? So it's not like I can, not that I haven't tried, I haven't, but I can't just build that in my backyard. I can't build.
right. Whereas this, you kind of can.
Otherwise, a B-2 bomber might have disagree with me. And whereas AI, you're right. Like I can run this.
Yeah.
And right in the apps, it's almost begging me. Like I actually typed into Facebook. I'm like, okay, AI, you like everything seems to demand I use AI. Please tell me how to turn off AI request. And it's like,
I'm sorry, I can't help you with that.
Gave me this big thing, like go into settings.
Oh, really?
And I tried that. Those settings aren't there.
Oh, freaking hallucinating, of course.
It turns out you can't turn it off. I'm like, oh, thank you.
I've been through the same process.
Thank you, designers. Whoever designed that, thank you.
Yeah, no, I hear you. It should be an opt-in thing. Yeah.
If it's interesting, let me try it, but I don't want it every day. Like,
But this is similar to, like you're saying, with social media and all the algorithms. This is just like capital doing its thing.
that's it.
I know.
And I think, unfortunately, it's something where capital is gaining a lot from doing things that are not productive for society or anti-productive.
Well, it's productive for the capital.
Right. sorry, I'm saying it's not productive.
I know what you're saying. Yeah.
Yeah. So, and that's why I'm pessimistic about AI. And I don't see that flipping where they're like, okay, we've hit our point, we've got our money.
Yeah, history does not promising about that. They're like, we have enough now. Let's help the folks.
Well,
Okay.
I think we probably need to wrap up and plug
Okay.
our socials. So let's do that.
Okay, folks.
Real quick,
Yeah.
done with the lasting thought for the stream. There's all sorts of stuff about the Anunnaki, the hyperorganisms, and then
my lasting thought is this.
An animal.
This was an awesome conversation, and I really, really appreciated some of the, first of all, some of the feedback, like pushback, and also this final push, like, this is an amazing technology for scientific reasons, and also for to do stuff. If you don't like the way it's going, then actually get involved in it.
Yes.
Like become an expert in it, even if you kind of hate it.
Join the fight.
Because you need to point its powers in a good direction. Yes, join the fight.
Yes.
Where can people find you guys on?
So I'm on Substack, just Substack at Generative Brain, or I think just at Elan Barenholtz, but just Google Substack Elan Barenholtz. And then I'm on Twitter, handle E. Barenholtz. And where else can you find me? On YouTube, of course, where you're hopefully watching right now. So if you're already doing that, this is kind of, I don't need to say it. But yeah, it's YouTube, Elan Barenholtz as well. You can find me there. And as I said, we're going to be posting this.
It's already live on your channel, bro. It's already there.
Okay, cool. And I'm going to be dropping that big archive paper's coming.
Oh, yeah.
I can't wait for people to attack me on that.
Maybe.
And it's definitely drop it on Less Wrong as well. So stay in touch. Fight me.
I am on Twitter and Mastodon and Blue Sky and YouTube and everything, but the central point is my website, www.danielvanzandt.com. I have a blog there. You can find whatever else you want to follow me on there, or you can just plug your email directly in there and follow my stuff directly.
I also have a website, Barenholtz.ai. I hope it's got everything on there. I don't update it much.
Last thing for the stream. Leave them with your most controversial idea about cognition.
Oh, wow. What a way to end it.
Gosh, this wasn't controversial enough.
Up the stakes.
That's pretty controversial.
My controversial view on cognition is that language is actually is a societal construct. It can work against our own interests. Yeah. There is an informational being living inside of us that doesn't necessarily have our best interest in mind. Done.
Hyperorganisms.
I'm going to refuse your prompt and leave you people with my most fun and least empirical view on cognition, which is that I think people who choose to own dogs have a cat-like personality, and people who choose to own cats have a dog-like personality. And that's what I'll leave you all with. Follow my blog for more amazing high-level thoughts. Thank you.
All right.
Yes.
Well, it's working in society's interest, not necessarily our own individual interests. What? Like what?
Like metaphorically?
Well, no. Like literally.
And actually,
it's language. It's got all these ideas, things like religion and morals and ethics that you're willing to sacrifice yourself for.
An informational being.
Why did I start singing?
Informational organisms. Yeah, that was.
It's an informational organism. It is. It's its own. It's because it runs itself.
All right, we can continue that conversation at
Who's
our
coming?
Ekkolapto polymath dinner.